What feeds effort? What feeds motivation? What feeds victory? With the most advanced scientific research, with the quality of the best ingredients, protecting people's health without banned substances and with transparency. Crown Sport Nutrition, your personal best brand.
Good evening. Well, good evening here in Europe, surely, but good morning for those of you who are streaming this event from Latin America. First off, I'd like to thank all those who are participating this morning or this evening in this event. My name is Kriza Radeska. I am co-director of the MA program in training and sports nutrition of the Real Madrid European University School. Once again, I'd like to thank my team for organizing this event, this 7th International Symposium, which yet another year is finally taking place. I'm very grateful to be here. I'm here, of course, on behalf of the school. I'm representing the school. Just to give you an idea, the Real Madrid University School was founded in 2006. So we've already had 18 editions, yearly editions of our masters. We have more than 38 programs altogether, and my masters is one of them. So it's been already 16, almost 18 years, which I've been involved in for almost as long. Now, this is the one and only masters globally, which tackles, let's say, both areas, training and nutrition at the same time. We have an incredible staff. You'll meet quite a few of them today. We have some top professionals in the whole world in both areas, in both fields, nutrition and training. And so I'd like to thank all of our speakers who are here today to share their knowledge with us, actually today and tomorrow. And I'd like to thank this opportunity to thank Guillermo Muñoz and Alejandro La Rubia, also co-director of the Masters. He's not here today. He'll be here tomorrow. He's more in charge of the training part of the program. I'm more in charge of the sports nutrition part of the program. So this was my introduction. I will shortly be given way to our first speaker, who will be talking about exogenic ketones in sports. His name is Jamie Whitfield. He's an expert in muscle metabolism and physiology. He's a researcher at the Mary MacKillop Institute for Health Research of Melbourne, and he's a member of the editorial committee of the American College of Sports Medicine. And for the next hour, Jamie will be delivering his presentation, and we'll have some time at the end of it for questions. So please send us your questions for Jamie via our chat. And that is it. Welcome once again, everyone. Jamie, you have the floor.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen a primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen a primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que es de las mejores opciones que puedo elegir estar en el Real Madrid. Solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
Yo creo que la llave para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Hi everyone, my name is Jamie Whitfield. I'm a research fellow at the Exercise and Nutrition Research Program, which is based in the Mary MacKillop Institute for Health Research at Australian Catholic University, and I'm currently working in Melbourne, Australia. So very happy to be here today, and I'm going to give you a sort of summary on the use of exogenous ketones in sport, and so hopefully explain what those are, some of the possible uses or rejections for their use in different contexts in sport, and sort of a summary of where the field is now. So to give you an overview of my talk, as you can see on the screen now, as I sort of walk through things, I'll give you a framework for testing supplements, talking about what we need to consider, ketones, so what they are and where they come from, discussing ketones as a fuel source, so using it to provide energy during exercise, some emerging research looking at ketones in recovery, so consuming them to help you recover from exercise, as well as some of the new and emerging areas that are being worked on by labs throughout the world. So whenever I look at a supplement, I try and put it within a framework. And so the implication here is that if training and nutrition are maximized, could supplements further enhance athletic performance? So that's the sort of question that we work from. And the implication here is that there is something inherently limiting performance, so some gap that needs to be filled. And it could be something like energy provision, so similar to consuming carbohydrates during something like a marathon or fats. It could be about providing that energy to support exercise. It could be something about byproduct removal. So, a buffering agent or something like that, removing lactate, if that's the limiting factor for performance. But one of the unknown questions is can this be improved beyond normal training induced adaptation? So as part of any training paradigm, working with coaches, practitioners, etc., ideally an athlete is improving over time through that training. And so the question is, can something like a nutritional supplement further enhance performance beyond what you're getting with training? Or potentially the question could be, can this supplement fill a gap in existing nutrition or training practices? So perhaps it's not about optimizing something through training, it's about filling that gap that isn't being addressed. And why is this important? Well, there's countless claims that supplements will improve performance. Every year there are new supplements that come out and are marketed and are supposed to change performance from everything from speed and power to endurance and recovery. But the problem with this is that human biology is extremely tightly regulated. So therefore, it's extremely difficult for supplements to have a sufficient impact, at least as they're marketed. So what questions do we need to ask when we're looking at supplements? Well, first and foremost is, do the supplements accumulate in the blood or reach the target tissue? So are they available for the system to use? The second question, what is the potential mechanism these supplements have to improve performance? So again, what is it targeting? How are we expecting it to enhance some aspect of exercise performance? And finally, has performance been measured, and is it different? This is probably the simplest of the three, but obviously for an athlete, it's the most important. Is there's strong evidence that a supplement is going to actually improve performance in a relevant capacity for what they do in their day-to-day. So if we think about athletic performance as a spectrum from speed, power-based events to endurance-based events, so as you can see on the screen, looking at the left-hand side, we've got something like the 100 meters, using this athletics as an example, which is obviously speed and power-based. So we've got different factors that might influence performance here, so neuromuscular and mechanical determinants of the muscle. Whereas if we shift over to the right-hand side, with something like the marathon, we've got other physiological determinants. But ultimately here, what we care about is performance velocity. So how fast can an athlete cover a given distance, and how fast can they run? But if we zoom out a little bit further, we can see that there are different factors that combine and interact in order to alter that performance velocity. And we can also interact with different nutritional supplements here. So you can see there's a whole host of different supplements that are being proposed to alter different aspects of this overall framework. And depending on what athlete you're working with or what supplement you're testing, that might alter what you're actually looking at. So if, again, in the context of today's talk, if we focus about ketones, there's some evidence to suggest it might alter economy. So again, energy production, energy provision, as well as the distribution of how that energy is being used. So again, putting it into the context of sort of this framework, I think is helpful. So why ketones? Well, this is a news grab that was taken from January of this year, and it was from Team Visma Lisa Bike, World Tour Pro Cycling Team, and they had just announced that they had a 3-year partnership with a US-based ketone company. And this is another screen grab. So again, another news article taken from last week, and talking about whether or not ketones are a cycling superfuel or marketing hype. And again, referring to Visma Lisa Bike, this is the most dominant team currently in the pro peloton. So this is a team that won all 3 major Grand Tours last year. So anything that they're doing is going to garner interest. This isn't a news story. So you can take screen grabs from different teams, different athletes over the course of a number of years, and you can see that there's a whole host of different perspectives on ketone use. So this screen grab saying that they should be banned, as opposed to discussion of regulating time trial bikes. And I think this article, and this is from 2020, so it's getting a little bit old now, but I think this sort of sums up all those other ones, is understanding ketones. What do they actually do? And so that's probably the area where ketones are currently sitting in terms of use within exercise, is they sort of exist in this gray area where people aren't exactly sure what they're doing, and as a result, they're a bit uncomfortable with their use, and not really understanding how people are using them, why they're using them, and whether or not that's something that's appropriate for use in sport. So what are ketones? Well, ketone bodies refers to three molecules: acetoacetate, beta-hydroxybutyrate, and acetone. And these can serve as alternatives to carbohydrate and lipids, so fats, in order to fuel oxidative metabolism. And so these are produced naturally by the liver, particularly in situations in which carbohydrate availability is limiting. So if you were to consume a ketogenic diet, for example, so restricting carbohydrate intake, or undergo a prolonged fast, your liver will naturally produce ketones, and those are the three molecules there, in order to provide another substrate to the body. And these are readily used by most tissues, with the exception of the liver itself. And again, these are produced in various contexts. So what about them as a supplement? We know that the body produces them naturally when exposed to a high-fat diet, but what if we were to consume them as a supplement? Well, this sort of area of research really jumped off in 2016 in this paper from Cox et al. Published in Cell Metabolism. And what they did was they took well-trained rowers and they performed 60 minutes of exercise at 75% of their max, followed by a time trial. And what they did was they consumed a supplement. So in this case, you can see an example of the supplement on the right-hand side of the screen, and just tracked the blood ketone levels with the different exercise exposures there. So you can see on the y-axis on the bottom there, time, and this is the concentration of the ketones in the blood. So you can see we get a nice robust increase in these individuals. And what's critically important here is this is far beyond what you would see naturally with a low carb, high fat diet. As an example, these are really increasing the availability of these ketones in the blood for the system. And what we saw with this paper, and this is what really caught people's interest, was that there was an improvement in their time trial performance. So you can see here in the second panel that's on the screen, that's the distance that individuals were rowing. And there was a significant increase in individuals' rowing performance when they consumed ketones with carbohydrate as opposed to just carbohydrate alone. So this suggested that something unique was happening with metabolism. So if we think back to that framework that I presented earlier, there's now testing performance and showing a difference. But what about the mechanism? Well, they used indirect calorimetry, so measuring respiratory gases, so expired air. And what they did was they calculated the estimated use of different substrates as fuel. So what are these individual rowers actually burning to produce energy? And what you can see on the screen now is the contribution of those different fuel sources at the two different exercise intensities tested. So 40% and 75% of their max. And what you can see is that ketones were providing between 16 and 18% of the overall energy here, according to these authors. So that was quite substantial when we traditionally think of carbohydrates and fat as our two primary fuel sources. Suddenly now there's this third fuel that might be entering the mix and being able to fuel exercise and improve performance. So this was really a landmark paper at the time, showing that perhaps ketones could be a novel supplement that could fuel exercise. And that's sort of where the field jumped off at. So how does this fit with our supplement criteria? Well, again, one of the key points here is mechanism. How does this actually work? Well, there's some really old data showing in cardiac tissue from rodent models that there's actually improved metabolic efficiency when burning or oxidizing ketones. So using this to supply energy. And this was because there was greater energy released from beta-hydroxybutyrate. So again, one of those primary ketone bodies that we were talking about earlier, compared to pyruvate, which is a carbohydrate based source. So when looking at it as a 2-carbon unit, there was more energy released in this cardiac tissue when they were burning ketones compared to fat, suggesting it's more efficient as a fuel source. So again, putting this in context to that framework I presented, one, we're showing that there's an increase in ketone availability in circulation. So again, it's accumulating in blood. It's available to the body to use. In terms of mechanism, there's some evidence to suggest that it's a more efficient metabolic fuel and therefore might be important in the context of exercise metabolism. And 3, again, for an athlete, the most important, this was associated with an increased time trial performance. So from sort of an early standpoint, this seems like this fits all of our criteria and would be a great supplement for athletes to be using. So again, if we think back to that slide with the different contributions, traditionally what we think of with exercise metabolism is based on this simplified schematic here. So we have fatty acids and carbohydrates as our two primary fuel sources. Those enter the mitochondria and the TCA cycle or the Krebs cycle in order to produce ATP. What these authors have suggested is that there's this third pathway where we've got beta hydroxybutyrate or ketones, and those are also entering the TCA cycle and perhaps producing energy here. And so again, this is an attractive hypothesis, but hasn't been at the time robustly tested in humans. And so that's sort of where the field went next. So one of the questions that was asked was, can ketones actually drive mitochondrial respiration? So this is nice when you're assuming with calculations on respiratory gases that the ketones are providing an energy source, but what actually happens in the mitochondria and in the muscle? And so to answer this question, you can use a technique called permeabilized muscle fiber bundles. So you can see a picture of this on the screen. This is a small section of skeletal muscle taken from a muscle biopsy from human research participants. And you can see as you move from sort of the upper right-hand corner of the picture down to the lower left, that what you can do is under a microscope, you can tease apart these fibers. And so they're into individual strands. And then you use a mild detergent to poke holes, if you will, in the outer layer of that muscle. And by doing so, you can provide different substrates, so different metabolic fuels, carbohydrates, fats, ketones, etc., and actually measure how that mitochondria consumes those fuels and consumes oxygen in order to produce energy. And so that was what was done in a follow-up study. This was a study led by Heather Petrick at the University of Guelph in Canada, published in 2019. And in a really elegant study, what they did was they compared mitochondrial respiration using that technique that I just described in rodent tissue. So the left ventricle, so some heart muscle, similar to what the original paper had suggested, that there was an improved efficiency with ketones in rodent muscle, and that's in panel A on the left-hand side. Excuse me. They also used red gastroc from, so a skeletal muscle sample from rodents. And then finally, they did the same thing in human muscles. And so what I want to draw your attention to is what's in the red box here. So in this case, when they provided a ketone body to the system, you can see that there's really minimal drive on respiration. So if I can just get my cursor up here, you can see here, this is adding ketone bodies to the system. And you can see that there's not really a great deal happening here. So on the y-axis here, we have JO2, or oxygen flux, or oxygen consumption, if you will. And so what's happening here is an increase in oxygen consumption indicates an increased drive on respiration. But when we add ketones, they don't really seem to be doing much in human skeletal muscle. If you contrast that with the bars to the right, this is when we add pyruvate, so a carbohydrate-based substrate, and you can see that immediately there's an increase in respiration. And so what this is suggesting is that ketones actually have a fairly negligible effect in human skeletal muscle. So in this panel here in F, this is the percent of pyruvate respiration. And so you can see with the two different ketone bodies they tried, we had about 6 or 2% of respiration when using ketones compared to a carbohydrate. So regardless of what tissue is studied, rodent heart, rodent muscle, or human skeletal muscle, it doesn't seem like there is a great drive on respiration using ketones. So it doesn't seem like these tissues are actually using this fuel source in order to produce energy. So if we think back to that slide I presented earlier with those initial calculations, well, the authors actually went back and tried to repeat the same thing using a ketone tracer technique, and they actually weren't able to replicate their own findings. So this is adapted from a publication from 2020. And what you can see is, as opposed to the sort of 16 or 18% energy provision that you could see in the original paper, Now we're looking at sort of in the 2 to 4% relative energy contribution, whether that was in a low ketotic state or a high ketotic state. So just providing ketones at different levels at different exercise intensities. So again, perhaps muscle isn't actually using these ketones as a fuel source. So again, this matches really nicely with what the mitochondrial data was that was provided beforehand. So what about performance? Well, again, that's probably what people care about the most. So this is a study that was done in our lab, led by Jill Leckie, and this was in World Tour professional cyclists. So cyclists were randomized to consume either a ketone diester or a placebo drink, and given 30 minutes. This was given 30 minutes and immediately prior to commencing a standardized warm up, and then doing a 31 kilometer time trial on the bike. And this was designed to mimic the World Championship time trial course from that year. And what you can see is that the time is actually getting worse. So there's a greater time to complete that time trial in the ketone condition relative to placebo. And this was also associated with a lower power output. So pre-exercise ingestion of a ketone in this study had a 2% impairment in time trial performance. And this was strongly associated with an increase in gut discomfort and a higher perception of effort. So again, perhaps now that key point, that performance point, there's now studies showing that it's not consistently improving performance, which is sort of muddying the waters, if you will, about whether or not ketones are a good supplement for athletes to be consuming. This is another study from our lab, and this was in elite race walkers, which is a cohort that we do a lot of work with. And we tried to combine ketones under conditions where we thought perhaps the body would be best adapted to utilizing them. So if you think back to those slides with the mitochondrial data that I showed, it showed that muscle wasn't adapting and using ketones to any great extent. But we knew that ketones are produced naturally by the body in exposure to low carbohydrate, high fat diets. And so we wondered if perhaps prolonged exposure to this diet might also increase the capacity of muscle to use ketones as a fuel source. So what we did was we had individuals consume a low carb, high fat diet for about 8 days, and then we had them perform a series of exercise tests alongside a ketone supplement, as well as a 10,000 meter race. And so what you can see here on the far right hand side of the screen is this is what I'll draw your attention to. These are the individuals consuming a ketone supplement while on a ketogenic diet. So sort of superimposing those two dietary interventions on each other. And again, we're seeing the same thing. We're seeing a decrease in performance. So in this case, this was about a 3% decrease in 10,000 meter performance. So they're actually racing slower on that ketogenic diet when they're consuming the supplement. And again, you can see we've sort of superimposed the two things here, and there doesn't seem to be an increase in circulation of the ketones, whether they're consuming them at baseline on a mixed diet or following ketone adaptation. And there was no change in VO2 or oxygen consumption when consuming it. So again, even in situations in which the body might be best suited to using ketones, it doesn't seem like this is being used as a fuel source for skeletal muscle. So there's a number of studies now showing really mixed effects on performance with ketones since that original 2016 study. And indeed, there's even some literature that contradicts itself. So people have started moving to different paradigms and different scenarios, similar to what we did, in which ketones might be beneficial. So in this example, we have a lab that was looking at ketone ingestion with bicarbonate, and it was the take home there was that the co-ingestion of ketones and sodium bicarb, so a different supplement there, appears to be a well-tolerated nutritional intervention and stimulates high-intensity exercise in the final stage of a prolonged endurance event. So Perhaps it was a case that you just needed to consume ketones along sodium bicarbonate in order to produce improved performance. But shortly thereafter, another paper showing the opposite, and it said ketone intake during a warm-up for a 30-minute maximal exercise slightly impairs performance, independent of whether this was prevented by ketoacidosis was prevented by sodium bicarb co-ingestion. So again, this isn't something that is being consistently demonstrated across studies. So we're not seeing that improvement in performance regardless of the paradigm. And that's really, again, what athletes care about. So if we think back to that metabolic pathway slide that I presented earlier, again, with these sort of 3 complementary fuel sources, I think this works fine at rest. But during exercise, what's happening is the flux through those other 2 pathways, so carbohydrate and fatty acid oxidation, is so great that ultimately what's happening is there's a series of steps here that are going to back inhibit ketone oxidation. And I think this, from an evolutionary perspective, makes a lot of sense. Ketones were only really designed in the human system to be increased in periods of starvation. So why would the system be designed in a way such that those would outcompete carbohydrate or fats, which wouldn't be plentiful and available in a situation of starvation? So if you have those fuel sources, why would your body not use them? And so I think that's what we're seeing during exercise, is that carbohydrates and fats are simply able to outcompete ketones in terms of producing acetyl-CoA and other reducing equivalents, which ultimately are going to inhibit that metabolic pathway and provide more energy to the TCA cycle. And so you can see that there, some of the points of regulation where there's going to be some back inhibition. And so research currently suggests that it's unlikely ketones play a meaningful role as an energy substrate during exercise. So at least that mechanism, as we've sort of been exploring through last 20 minutes or so, it doesn't seem like that's a valid mechanism, and therefore that's maybe why we're not seeing that improvement in performance. But what about recovery? So research has sort of pivoted away from looking at strictly consuming ketones before exercise in order to produce an improvement in subsequent performance. But what about recovery? So in this study, consuming a ketone supplement during an intensified training block was shown to prevent symptoms of overreaching. So you can see power output produced during a 30-minute time trial here over the course of an intensified training bout. So we've got week 1, 2, 3, and then during a recovery. And the black dots there represent the group that is consuming a ketone post-exercise versus the white open circles, which consumed a placebo. And so male subjects in this study, and they were participating in 2 training sessions per day for 3 weeks, 6 days per week. And they were receiving either that ketone ester or a control drink following each training session. And so again, you can see there's sort of that separation there that occurs by about week 2, where the power output is increasing in the ketone group, whereas there's a bit of a stagnation there in the control. And you can see that in panel C, on the right-hand side here, where we have an increase in the power output in that group. So potentially being involved rather than as an energy substrate, it perhaps is improving recovery. And there's some other evidence that might lend itself to suggesting that. So these are just some Western blots that were taken from participants following an intense one-legged glycogen depleting exercise bout and into recovery. And they consumed a protein carbohydrate mixture with either ketone or placebo. And so this is looking at sort of proxy measurements of muscle protein synthesis. So how is the muscle actually using these building blocks that are being provided to it to build new muscle? And these are sort of the key intracellular signals that are measured in that case. And again, when we look at the group that consumed the ketone supplements, so in this case, in the gray boxes here, there's an increase in some of these indirect markers, suggesting that potentially muscle protein synthesis is increased in individuals that are consuming a ketone. So perhaps with that previous slide with the intensified training bout, maybe ketones are actually activating some of the signals in the muscle to help you recover following exercise. And this group followed up on that with some cell work and showed the same sort of thing. So again, looking at muscle protein synthesis through a pure myosin stain. And what they showed was that when you incubate cells with super physiological, so really high concentrations of ketones, you get this increase in protein synthesis. So suggesting that perhaps this is sort of the new mechanism that ketones could enhance overall performance, is that we get an increase in muscle protein synthesis when we consume ketones. And this is some really, really new data. This was just published in January from a group in Canada. And they showed that in a randomized double-blind parallel group design with 36 recreationally healthy young males, when they actually measured muscle protein synthesis directly using a continuous infusion of a stable isotope, they did not see a change in muscle protein synthesis. So whether they were looking at the early phase of recovery, so 0 to 120 minutes or out to 300 minutes, whether individuals were consuming ketones, again, bringing up my laser pointer here, so ketones, protein, or a combination of the two, there was no difference between those treatments. So there was no difference in the actual measurement of myofibrillar fractional synthetic rate, so direct measurements of muscle protein synthesis. And they did the same thing looking at some of the indirect markers, and again, there was no difference between them. So again, despite some early enthusiasm and excitement in the literature, it's not really following up with under scrutiny that ketones are enhancing, in this case, recovery through muscle protein synthesis. So perhaps it's a different mechanism. And so again, looking back at this piece here from that overreaching signal, what people have done is actually taken a pretty close look at some of the different aspects of this study. So maybe it wasn't actually ketones that were enhancing the recovery and blunting overreaching. One of the key things that is being pointed out is that the energy intake was actually significantly higher in the group that was taking a ketone ester. And specifically, there was an increase in the carbohydrate intake, especially during week 3 of those individuals. So perhaps what we saw with that separation in terms of recovery wasn't actually drawn out by the ketones. It might actually just be that they were consuming more energy and fueling better and recovering better as a result of the increase in energy intake. So again, sort of summarizing that point there, the subjects in the ketone group spontaneously increased their total energy intake by about 20%, and most of that was due to carbohydrate intake, so almost 30% at week 3. So again, maybe it's not the ketones here, there might be some other things that are at play. And just sort of moving to wrap up here, some of the new and emerging areas of ketones, again, this is something that has 9 lives. We sort of knock down one possibility for ketones and something new pops up. So again, some pretty new data here. This is from 2023. And what was really interesting in this study was they showed that consuming ketones, so you can, again, in panel A there at the top, you can see the increase in ketones in blood circulation. What was interesting in this study was that they did 1 hour of cycling, alternating between different intensities, and then consumed a ketone drink. But what was found in this study was they actually detected an increase in serum EPO following the consumption of ketones. And you can see that quantified there in terms of the area under the curve, where there's a significant increase in serum EPO following the consumption of ketone bodies. And so that's sort of driven a new question here. Could ketones augment the increase in EPO secretion following exercise? So we know that exercise naturally increases EPO, at least to a small extent. You can see that with the white open circles there, but maybe ketones are augmenting that. So you can see that increased area under the curve. And again, some individuals have retrospectively taken some of their samples from that overtraining study and measured that, and shown the same thing here. So looking at pre-post training, there's an overall increase in serum EPO in individuals who are consuming ketones post-exercise compared to the control. And they also had an increase in markers of VEGF, which is associated with angiogenesis, or the creation of new blood vessels. So again, that was correlated with the change in serum EPO. So again, some new areas here, and stuff that's really just beginning to be explored. So again, this is another paper that was published in 2023. So some new areas that are still being tackled. So let's sort of summarize everything and put it back into that framework. So again, there's countless claims that supplements will improve performance. I think I've hopefully shown that with ketones as well, that it's being proposed in different paradigms and different situations that might be a performance enhancing supplement. But again, biology is really tightly regulated. So we saw that with that mitochondrial data. It's very difficult for supplements to have a sufficient impact beyond how the body is already built and regulated. So again, looking at those questions, does the supplement accumulate in blood or reach the target tissue? What is the potential mechanism of action? So how is this supplement going to alter metabolism or performance? And again, has performance been measured, and is it different? So looking at ketones here, and the potential mechanism, I've shown you that ketones, sort of as a jack of all trades, has been examined pre-exercise and during exercise to improve performance. It's being taken with and without exercise. There's also some work, I didn't show it today, but looking at consumption at altitude or in hypoxia. There's now some work suggesting that ketones might be beneficial for acute recovery. So promoting, again, I didn't show this data, but enhancing glycogen resynthesis, as well as being involved in muscle repair and protein synthesis. And then there's been a host of other sort of situations in which ketones have been proposed to be beneficial. So again, we've discussed its role in potentially reducing overtraining, but there's also some work looking at cognition, enhancing sleep. We discussed EPO secretion and blood vessel formation. And also some of the work that we've got ongoing in our lab currently is looking at its role in reducing appetite and assisting with weight reduction goals, specifically in weight-bearing activities. But the problem is when something is proposed to be a jack of all trades, chances are if it's that unspecific, it might not be as effective as perhaps it's being marketed as. So again, hopefully what I've shown you today is that some of these points here aren't really holding up to subsequent scrutiny. So there's not really a strong evidence to suggest that there's it's acting as a fuel source when taken before or during exercise. And then the same thing with the muscle protein synthesis and glycogen resynthesis, the evidence there is quite mixed. So this is something that more work is definitely needed. And that's perhaps one of the limitations here. So summarizing some of that research that I've discussed today and where things are today, the performance literature is really unclear. And part of that is due to the contradictory results. So I showed you one example of that with the sodium bicarbonate. But since that 2016 paper that proposed improved performance, it's been really mixed in different cohorts, whether it's cycling, running, rowing, and in different situations. So if it's not consistently showing an improvement in performance, it's really difficult to recommend this to athletes. And part of the problem here is that there's so many different protocols being used. And so as a result, it's really difficult to make comparisons between studies because they're being used in different ways. One of the other issues, especially within the lay media, is the confusion around the word ketone and supplements and the different forms that they occur in. So there's obviously esters, salts, and those will have different biological effects. But there's also things like raspberry ketones, et cetera, which have been marketed for for weight loss, amongst other things. So there's a bit of confusion about what ketones actually are, and I think that's part of the issue and why people are so confused about them. One of the other things as well I'd like to highlight is the underground practices and secrecy around the use of ketones, specifically in pro sport. Because teams are inherently unwilling to share what they're doing, because obviously they want to be the best in their given realm, this leads to sort of discussion of illegality. So if something is perceived to be on the gray area of things, it must be good, and that sort of drives its popularity. So again, with that team Visma Lisa bike, because they're so dominant, but it's not clear how they're using it, the implication that people have is, well, this must be a great supplement. This must be what's supporting their performance, and that drives its popularity, despite there not actually being any real evidence to support that. So again, definite evidence and guidelines are preferred for the use of supplements where available. The next point there, the biochemistry and metabolism involved here is incredibly complicated. So even with that simplified slide that I showed and some of that metabolic regulation and mitochondrial data, this is really advanced physiology. And so it can be difficult to predict or understand the potential uses of something like a ketone, given how many points of regulation there are. And again, as I sort of alluded to with that previous slide, the jack of all trades marketing of ketones. Many of the benefits are claimed for direct performance, but we need more research and replication of studies here. And that replication piece, I think, is the key thing, because often when people do repeat studies, they don't show the same effect. So it's easy to get carried away with one sensational result, like that 2016 study. But it's important that people are doing follow-ups and validating this and showing the same effect in different labs. So this is sort of the way I like to summarize a lot of different supplements, and it's a quote from Professor Ron Mon. So 1, if a supplement is not banned, it probably doesn't work. 2, if a supplement works, it's probably banned. And unfortunately, 3, there are some exceptions. So with that, thank you very much, and I'm happy to take any questions that might be available.
Thanks, Jamie. Well, I have one question. Blanca Co. Sanchez asks, you mentioned that the consumption of cetones could aid in recovery by reducing fatigue symptoms. These symptoms refers to each athlete's subject perceptions?
So that's certainly something that would need to be considered. In this case, the fatigue was measured based on looking at performance in response to that overtraining. So I can actually hopefully bring that up on the screen there. Excuse me. So what we're referring to with fatigue is how these individuals are able to produce power in response to that overtraining stimulus. So in this case, looking at that separation of power output over the course of time. So they're not developing fatigue to the same extent in terms of a performance outcome, so being able to generate power. But yeah, certainly monitoring the fatigue individually within each athlete would be a critical step, and using some of the surveys that are available for practitioners now, and looking at sort of mood states and other things. I can't remember off the top of my head if they did that within this study, but yeah, that would certainly be an important aspect. And I'm not sure how well that's being looked at with ketones. As I said, there is a little bit of work now looking at cognition, but I'm not as familiar with that literature off the top of my head.
Okay. Well, I think that I have not questioned that. Not okay. Well, James, thank you very much for another question. Sorry. If there is a risk of ketoacidosis, how this correct or compares to minimist?
Yep. So that was some of the work that was done with sodium bicarbonate. So because there is an acid component to these supplements, there will be a change in pH when consuming the ketone supplements. And so that was the question behind consuming them with sodium bicarbonate at the same time. So sodium bicarbonate is going to buffer some of that acid load in the blood. And so by consuming the two supplements simultaneously, the idea was that you would get the beneficial effects of the ketone supplement without having that drop in blood pH or that ketoacidosis. But again, unfortunately, the results on that are quite mixed. So there's some work from Canada that has shown without the sodium bicarb, you do have that drop in pH, and that's associated with an increased perception of effort, as well as increased ventilation and drive on the respiratory system there. And that's from Marty Gabala's lab in McMaster. But again, when combining it with the sodium bicarb to prevent that, it doesn't seem to be a clear effect that's preventing all the negative effects. So again, how you can completely minimize it, I'm not sure, because it hasn't shown to be consistently beneficial in that case.
Thanks. Excellent. Jamie, thank you very much for your presentation. And now, bueno, ahora hablo en español. Gracias, Jamie. Vamos a pasar con nuestro siguiente ponente. No sé si pasamos ya. A ver que me indiquen.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen al primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional, y es el inicio de ese proceso de crecimiento.
De las mejores opciones que puedo elegir estar en el Real Madrid, solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
Yo creo que
las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen al primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional, y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que de las mejores opciones que puedo elegir estar en el Real Madrid, solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
creo que la llave para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen al primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que de las mejores opciones que puedo elegir estar en el Real Madrid, solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
Yo creo que la llave para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Hello again and welcome back. I will now have the honor of introducing our next guest. His name is Reinaldo Garcia. He has a degree in nutrition from the Central University of Venezuela. He's an expert in exercise physiology with a master's degree in this subject from the Caracas University of Venezuela. He's currently research coordinator at the Baylor College of Medicine in the US. He's also acted as scientific consultant for Gatorade Sports Science Institute in Latin America, for Latin America. He was a sports nutrition professor at UCV, and he's a guest speaker and guest lecturer at various different Spanish and American universities. And he has an addiction. He's addicted to endorphin. So thank you very much for being here. It's a privilege to have you here. I actually worked with him. I was tutored by him quite a few years back. He's an incredible expert in sports nutrition. I'll be, obviously, as always, reading your questions on our chat. So feel free to send as many as you want. Thank you. Thank you, everyone. Yeah, well, I think you're one of those cases, I can say, dear Kriza, where the student outclasses the master. Thank you for the invitation. So this presentation is called The Alchemy of Fluids. And I'd like to tell you a story. This story began in this field. This is the football pitch of the Central University of Caracas. The school itself is that building over there at the back of the picture. And I've been practicing sports my whole life. I used to train here, in fact, and one day I was training here. I'd been training football in this very pitch for about 90 minutes at this point, and I had a friend who was there as well. He was a triathlete, and after that training session, we both started drinking Gatorade. It's a sports drink that's widespread in a number of countries. It's an easy solution, an easy beverage to turn to when you're dehydrated. It, it was later shown actually that in Latin America, Gatorade was a bit more watered down than it was in the US. In the US, Gatorade was a lot thicker, right? And I was very fascinated by this. The Gatorade was more watered down in Latin America, thicker in the US, and that's one of the reasons why I decided to study sports nutrition. And on that very day, I started pondering about whether it would be better or worse for a sports drink to be thicker. How to answer that question? That's the question I'd like to answer today. Now, human beings are both endothermic and homeothermic. It means we regulate our own body temperature, and that temperature needs to be kept at healthy levels, which is between 36 and 38. If the temperature rises too much, what we have is hyperthermia. If it gets too low, what we have is hypothermia. So our body needs to regulate its own temperature. And to do that, there are a few mechanisms it can employ, some of them physical, others, let's say, more conceptual, meaning if it's hot, you wear lighter clothes, etc., etc. But anyway, we are endothermic animals. We produce heat. But when we're training, obviously, when we train, our body temperature can increase by up to 1 degree every 5 to 7 minutes. And if we don't find an effective way of regulating that body temperature, there's no way we'll be able to run for a long time. And so there are a few things we can do. We can use radiation, that's the environment around us, perspiration, but obviously the most effective mechanism that a body has at its disposal to regulate temperature is sweating. It's perspiration, because water droplets cool down our body, they cool down our skin, and that allows us to keep on doing physical activity when we need to. Now, in this table, we have several different people doing exercise at different temperatures, 10 degrees here, 20 and 30. And this is a breakdown of the extent to which each one of the body's cooling systems comes into play at the different temperatures. At 30 degrees, as you can see, perspiration is the most effective technique to control temperature, as is when we do exercise for a very long period of time. The issue is that when we sweat, we easily get dehydrated, and dehydration at a certain point will begin to affect performance. Now, each one of us produces different quantities of sweat, and so it's difficult to make a standardized recommendation for water consumption during exercise. For some people, 1 glass of water during a training session could be enough, but for others won't. On average, however, we sweat out about 1 liter per hour, but there are people who can sweat out up to 2 liters per hour. For example, American football players playing in humid environments. On the other hand, on the other end of the spectrum, we have, for example, a girl, skinny girl, taking a walk, taking a trek up in the mountain. She won't be sweating as much. And so the amount of water we have to drink during exercise changes. But we can't afford to get dehydrated ever. That's the most important thing. Now, up to a certain extent, dehydration can be tolerated. up to 2% of your initial body weight lost in sweat is tolerable. More will begin to affect your performance. This, anyway, is the result of a study where scientists tried looking at dehydration in athletes and performance. Actually, many studies have been done, up to 60 that I know of, and 41 out of them, which is 68%, showed that that is actually correct. Up to 1 to 3% of initial body weight loss does not lead to significant reductions in performance. But let's try and come up with some estimates, because it's very difficult to try and predict how much liquid we'll lose when exercising. In this particular study by Pass and others, we had people running around for 16 kilometers, running track, and all the athletes consumed different types of drink. They measured how much weight had been lost in sweat. They asked them how much sweat they thought they'd lost. They asked them how much they drunk. They asked them how much they thought they had. This is the result. This is the amount of sweat that was actually lost, and that's the water intake. Now, all athletes were quite accurate in estimating how much liquid they had drunk throughout the exercise. But their estimate of the amount of sweat they'd lost was a bit poorer. On average, each of them sweated out about 1.83 liters of water an hour, but they thought they'd lost about 1 hour. And when we asked them, most of them said, no, I don't sweat a lot. That confirms that we are bad, actually, at estimating how much we sweat out liquid during exercise, and that's why it's important to weigh ourselves before and after a training session, before and after the hour. Another important factor is that they only replaced about 30% of what they thought they had lost, which once again confirms that we humans aren't particularly good at estimating how much we've sweated and how much we should drink during exercise.
To the extreme of not drinking anything, because, for example, they were not available, or maybe you have drunk too much, they could have the opposite effect. I don't know if you're familiar with Gabriela Anderson. She's story. You can find her on YouTube. We have a full interview about her case. She participated in the LA 1994 Olympics, where it was very hot, and she had problems to hydrate herself. And the end was quite dramatic. And we have the extreme case of Cynthia Lucero that was running the Boston Marathon. It was very cold, and she drank too much. And this created a hyponatremia that killed her. So we have an important range of intakes, and this depends on what there are different recommendations for every person. So you know how these stories ended. So now let's speak about hydration physiology, and it's important to understand how we can make athletes to hydrate better. And this starts with acceptance, with consuming something that makes us drink a lot. Because if you sweat more than 1 liter per hour, you'll need to drink something that you like. You can have an ideal drink to hydrate, but if it doesn't taste good, if people doesn't have it, there won't be hydration. Next step would be the gastric emptying, intestinal absorption, energy, and liquid retention in the body when we are doing exercise. We will deal with them quite briefly. So quite an interesting detail is that the drinks that make us what makes us drink changes throughout the day. Maybe you want to have a mate in Argentina, you want to drink a coffee. If it's Friday you are hanging out with your friends, you want to drink a beer. when you are working out, we have seen some indicators that make people consume more in exercise conditions. So it's important that our appetite for beverages changes, and especially changes when we are under heat stress or we are dehydrated. So it's important to take this concept into account. Of course, it has a lot to do in acceptation. And this phenomenon was started to be analyzed in military, in soldiers. We see one of the reports that have been published analyzing this effect of the intake of different beverages. This case, it was 14 subjects doing exercise for 6 hours at 40 degrees Celsius at relaxed places. They have these work and break cycles of 30-30 when they had an unlimited intake. One of the beverages was cold water, another one was cold water with a taste, with a flavor, and the other one was warm water. And basically, they compared the scenarios when the soldiers consumed more liquids when they were doing exercise. Here you see the hours and the intake volume. Basically, what you can see here is that cold water with a flavor was much higher than the others. And the warm water, the tasteless water, was the least consumed. So the first message is that if we can hydrate the athletes with cold waters, with cold beverages, will increase the amount they consume during exercise. And this is especially useful for the people that do not want to consume, because it will help them drink more. So that's the first message that we could learn out of these studies about how changing some details of the beverages, we increase the acceptance and we increase the intake too. So we can see this among children using flavored water with sodium, for example, and see that when the sport beverage with sodium was consumed, I mean, it was that they consumed more during these 3 hours compared to just water or flavored beverage. If we can make it have a flavor, or if we can cool it down, it will always be better. So this would be the first step in terms of acceptations. But that's just one part, because the fact that, well, everything is affected by other factors. I've talked about the factors like flavor and sodium, for example, but there are other elements that make us take more liquid, like, for example, physiological thirst that is related to loss of fluids, and hyperosmolarity. This creates more thirst, and there are other social, cultural factors that has a great impact on the wish we have to drink. So although we can have an influence on these things, we need to take into account that there are other relevant factors that have an influence in terms of what do we drink during exercise. That was the first step. The second step is quite interesting, because it is how these liquids go from the stomach to the gut. So one of the first studies in order to measure that gastric emptying was through the nasogastric system, putting them through to the end of the stomach. They were working out, they drank through the syringe the amount of liquid in the stomach was sticking out, as you can see on the picture. And obviously, if they had more liquid in the stomach, the liquid that had the most amount in the stomach is where the gastric absorption was the slowest. So that is an important factor to take into account. So with these studies, it was found that when the beverages had more than 800%, 8% of carbohydrates, that absorption was slower. So the idea was to take blood samples from time to time, after 5-10 minutes until 2 hours. And the interesting thing is that this is measuring the inclusion of the liquid in the blood, and there we are integrating the intestinal absorption and the gastric emptying. So this gives an idea of the total availability of liquids. And here we see the results. We see that when they had more than 6% of carbohydrates, we see that 9% of carbohydrates, the gastric emptying was slower. And this is why it's recommended that a beverage with carbohydrates shouldn't have more than 6% or even 8%, because the glucose in this case affects the fluid supply. But once and again, this is not the only thing that matters. There are other factors that play a role in gastric emptying, like, for example, the density. For example, if you have a chocolate milkshake, it will take more time, and your stomach will take more time to empty because it has more energy. And other factors like the exercise intensity. So as we keep on needing more intensity, this has an impact on the gastric emptying. And if we are dehydrated, the gastric emptying would be slowed. There are other factors like osmolarity, the sodium content, pH, or temperature, and other factors that play a role in the gastric emptying that are volume. That is, the more we take, the quicker the gastric emptying happens. So in this case, we should think of train in order to take more, because this will help us speed up the gastric emptying. If we sweat a lot, we'll lose a lot of sweat. This will help us be better hydrated. And we have other details, like, for example, different contents of different combinations of carbohydrates, or the presence of different carbohydrates will also help speed up this gastric emptying. And we keep on going down from the stomach to the gut. So we'll see important details and interesting details. As you see, the gut absorbs everything we consume, but essentially it absorbs water, and it is absorbed through different mechanisms like electrochemical gradients and transporters. These specific transporters have to do with a transporter that includes the water passing, the sodium passing, and glucose passing. So this transporter is identified with letters. It includes sodium, or glucose, and sodium increases the osmotic gradient and increases the amount of water that can be absorbed at the intestine. And this is the main reason why many beverages have carbohydrates and sodium, in order to try to help produce this phenomenon of a higher absorption of liquids at the gut. In fact, this discovery that glucose and sodium were coupled was maybe one of the most important milestones during the 60s and the 70s, and this helped us many lives being saved from dehydration. There are other transporters for other carbohydrates, but this increases the amount of carbohydrates that are absorbed. These are the fructose transporters, and it would increase the amount of liquids that could be absorbed in the intestine. So we have different kinds of carbohydrates in the intestine. It's like if we could open different gates for more water to come in, and this would allow us to be better hydrated or to get more energy, and this would allow us to increase the carbohydrate absorption during exercise. That's an important detail that we'll see in a minute. So there are other factors that play a role in intestinal absorption, like hypertonicity. Very hypertonic beverages will take more time to be absorbed, or beverages that only have fructose, or again, the exercise intensity. If you have a higher intensity, it will affect the intestinal absorption. So the higher the intensity is, the more the bloodstream redistributes to all the areas that are doing that exercise. So this is why it has an impact on the absorption and the gastric emptying. So this is one of the reasons why the intensity affects the whole process. We have other factors that don't have that impact, like sodium, pH, or temperature, because if there's a lot of sodium, or maybe if the beverage is cold, when it is in the body, it gets at the body temperature, so it doesn't have a very high impact. And there are other factors that speed up these, that accelerate these absorption. If the gastric emptying is high, we'll be able to increase it, and other factors like carbohydrates, or beverages with less than 8% of carbohydrates. So 3 steps: accepting acceptance, gastric emptying, and intestinal absorption. And another important detail is about the reabsorption of liquids at renal level and the distribution of these liquids in the body. To hydrate is a very good idea, but if we are at a race, for example, we have to urinate because, well, maybe we could be wasting time. So some of the studies made with sport beverages show that the intake should reduce or could reduce the urine production during the exercise. But it's very important to see that these reabsorption is very important to keep that plasma level, keep that cardiovascular balance, to help us regulate the temperature. So the idea is that if we drink beverages, we should avoid them from being lost. And this can be accomplished in two ways. First of all, we could stimulate the renal absorption of water, and the other one would be to reduce the appearance of intaken liquid in the bloodstream. So it will depend on how quickly these components could appear on our bloodstream. So there are studies that when compared water with sports beverage, they showed that around 33% or about 30%, I mean, there was 33% less urine during the exercise. In order to reduce this amount, a higher amount of sodium was necessary. So we have a higher intensity of exercise, the urine amount would be reduced by itself, and this wouldn't be a problem. Another scenario is what happens after the exercise. And in this case, we could also think of some beverage to drink before, during, and after the exercise. And we'll speak about an interesting detail here that is called the beverage hydration index. What they did here was to take 72 subjects, and they would consume 1 liter of different beverages in 30 minutes. They have 13 different beverages, and they compared these beverages with water. What they did was to measure the urine production. If they produced less urine, more beverage was in the body, and the retention level, the hydration level, would be higher. So let's see the results here. And this is the classic curve we see when the exercise hydration studies are made. We have the net fluid balance, and here we have the time after drink. So when we see them, they will start to drink the beverages, the net fluid balance is positive. This is close to 1 liter. This was the amount consumed. We see that this liquid is lost through the urine. We see that there's an important difference here. And after 2 hours, there's another important difference. It was basically that the whole milk and oral serums caused a higher liquid retention compared to other beverages that were compared, that were, for example, fruit juices, sports beverages, water, and other additional beverages. So this is why it's so popular to think that an ideal beverage for, after working out would be whole milk, because it will help us retain the liquids that we are consuming after the exercise. But there are important details here to take into account. Usually, number one is that, well, I don't know in your case, but I wouldn't have whole milk during the exercise because I think that it can be very heavy. There are things that could be positive, things that are in the milk, but for example, like carbohydrates or fats could be negative. Maybe I could think about it after exercise. And another important aspect in these studies is that they drank these beverages and they spent some hours in the lab to wait more urine to be produced to see the amount of liquid that was retained in the body. But usually, this is not a real life condition. Usually, sports nutritionists recommend that after working out as quick as possible, try to eat to help with your recovery, especially if you are training to compete or you're training several times a day. So an athlete will spend 2 hours. You shouldn't spend more than 2 hours without eating after working out. So if you eat rice with meat and a beverage, this food will delay the urine production because it will delay the production of these liquids in the body. So we will need to have these hydration level. And we would need a different beverage after the exercise. And the last point would be the energy point. That's very important. I don't know if you are a great fan of Helio Kipchoge, but remember in 2017, he tried to run in less than 2 hours. It was 2 hours 25 seconds. So I spent the whole night watching the race. So it was some kind of test to see if he could run in less than 2 hours. But this guy was analyzed by Dr. Andy Jones that was participating in that project, and this was taken from an interview. So he says that Elliot ran out of fuel. He says that could have been the limiting factor. If we could find a way to have more glucogen or to consume more carbohydrates during the event, and this would help us reduce these barriers. So he did it quite a short time ago. But if you're thinking of a beverage, for example, that has this carbohydrate level, I mean, carbohydrates are there to help us improve our performance. Sorry, you'll understand that carbohydrates are important to increase performance. But I wanted to bring this figure that comes from the review of the carbohydrates that have been consumed during exercise, and 50 out of 61 studies included 679 subjects. 82% of the reports showed an improvement. 82% of the athletes that consumed carbohydrates showed an improvement in performance. So carbohydrates help us improve our performance, and this is why I would always think about having a carbohydrate in beverages. So cold drinks, for example, and citric flavors help us improve our performance. We have talked about gastric emptying, for example, when we have more than 8% of carbohydrates, one of the reports that we've seen, etc. The intestinal absorption with sodium and carbohydrates, they play a very important role, and the distribution of these exercises. So these are details that we need to take into account when we are thinking about how to create an optimal beverage for athletes. Well, we've seen many things in 30 minutes, but I just drew the conclusion that I didn't need a denser, so to speak, drink. But I would like to give you some ideas about how to think of all this from a wider point of view, to open the screen in a much more wider approach, I would say, to look for the details that could be more helpful in improving hydration. So I'm going to share some specific ideas here. One of these ideas would be, what happens when we mix beverage and food? It's quite common in cycling and triathlon. This image that we see, well, I love it because it shows a summary of what a triathlete could be consuming if he's participating in an Ironman in breakfast, for example, or at a snack before getting into water, swimming, cycling, race, trying to reach 60 or 90 grams of carbohydrates an hour. It would be interesting to see how this mix could affect this gastric emptying and this intestinal blow, but it's quite difficult to make studies to measure the impact of this food consumption. But today we know that athletes tolerate it, and an important part of tolerating it entails to be trained to tolerate it, not to get there on the first day to try to consume all these carbohydrates, but progressively using the training sessions as a lab in order to reach these amounts. So it would be interesting to see what happens in the future with the acceptance, the gastric emptying, and all these things, to see how it affects the absorption. it would be an interesting detail that we still don't know. And other things, like, for example, what impact, I mean, how much can we tolerate with the intestinal training? Increasing the tolerance as time goes by. It can be 10%, 40%, 50%, I don't know. But it would be interesting to know that our body can adapt to consume higher amounts of carbohydrates and liquids during exercise. And well, knowing that the hydration or some details can improve the hydration, like for example, temperature or 8% of carbohydrates could be quicker. It is very important that we adapt this information to the athlete context. So how much time does he have? Does he have the possibility of consuming during the exercise? How long does it have to adapt to the training session? And another very important point would be how much they should drink. And it's important to make an estimate of the sweating rate to see the amount of sweat, to see whether we need to consume carbohydrates or not during the event. If the event's very long, it will be more important to consume the carbohydrates. And with the replacement speed, I mean, when this person is going to train again, for example, on Monday, this person was running the Boston Marathon, maybe this person won't train maybe today or tomorrow because they are resting. So how quickly do I need to restore that glycogen depending on whether I have a subsequent session or not? So every detail is paramount. It's important to take them into account. And of course, we need to adapt the different recommendations to the athlete context, and we need to make a personalized alchemy to try to make this to try to make it fit to the athlete so that he can be totally hydrated. So, as a good teacher, that's a task right now. Now that you're watching this presentation, the task for you is to look for sport beverages that you have in your cities or whatever, and you have a look at the labels to see the carbohydrates composition, the products that are available in your countries, in your cities. If you have to take these three takeaways out of this talk, is that they have to taste good, because maybe you have to consume several liters. Maybe you have the ideal beverage, but maybe it's not at the right temperature, so it's quite difficult for you to consume enough. Second point would be that it has carbohydrates, especially if you want to improve your performance. It's very important to consume carbohydrates during exercise, and consumption could be up to 90 grams an hour. That's a lot. If you want to improve your performance, that beverage should have that fuel. And I would also think on sodium. Think of sodium, sorry, because sodium, as we've seen on the first slides, increases that wish to drink, and this allows us to keep on hydrating more ourselves. Many times we've seen that on the ground, the athletes are not drinking anymore. And we see that sometimes they are dehydrated, because sometimes if they are doing exercise first wouldn't be a reliable indicator that we are hydrated. And we've seen that on the experiment with the athletes that were on the list. So I hope that I've left some interesting ideas for you, or to understand this better. And now I would like to leave you with this sentence that I love from Enrico Fermi, that was the one that created the first nuclear reactor in the world. And I hope that this has happened to you. He went to a conference and he said that before coming here, I was confused a little bit this topic. And after listening to your conference, I'm even more confused, but at a higher level. So I hope that you are at a higher level about this topic after being with me today. And well, thank you very much for having me. Thank you very much for listening to me, and I'm fully available for your questions. Thank you. Great, Pedro. Thank you very much. Well, honestly, I love to listen to you. I love to listen to everything. So any questions? I don't know the name of who's asking it, but how can we calculate how much we need to hydrate during different events? For example, push-ups, short training sessions, um, and swimming, and to have a tailored plan. That's a very good question. And I regret on having removed these slides from the presentation. I always repeat this, but it's very interesting because it is something that is quite simple to do, and it's something that is available for almost everybody that has a weight to basically to weigh them. We only have to be careful. The ideal thing is that they can weigh themselves before working out. They work out. It's usually recommended to do just 1 hour. And after that, they weigh themselves again in the same condition. So ideally, in underwear or naked, if they have the possibility being close to the bathroom, they're going to have the training sessions, or at home. Because if we train and our clothes are basically wet with our sweat, we will weigh more. If, for example, we weighed 70 kilograms before getting started, and we weighed 69 kilograms, it means that we've lost 1 kilogram of weight. And usually these important losses are usually liquid losses. So this means that 1 milliliter is like 1 gram of sweat. So if you've lost 1 kilogram of weight, you would be losing more or less 1 liter of liquid. So we should repeat this process several times, because the amount of sweat also changes depending on the intensity of the training session. Low intensity, high intensity if we are training during winter, during summer. So this amount of sweat that we produce will change. So if every person that is working out does this before and after and sees these differences in weight, will understand better how much they sweat, and as a consequence, they more or less know how much liquid they should intake. For example, if they are losing 1 kilogram, that would be more or less 1 liter. They could think that, well, one idea would be to consume close to 50%, half a liter during exercise and half a liter after the exercise to try to compensate some of these amounts that could be lost. But that's a very important question, because that's one of the easiest strategies that we can apply in sports management. And people that do that learn a lot about how their body sweat to see how much they should drink. Yeah, that's the point. So the ones that work with athletes, I mean, they know themselves depending on the season. If it's hot, if it's cold. Here in Europe, the seasons are quite very well differentiated. So the sweating rate changes, of course, depending on the season. It's quite a simple strategy. So we have 2 questions that I'll try to ask them at once. One of them reminds me of university, so it would be easy to answer. So in what case it would be convenient to use sugar beverages or gas beverages during exercise, and any piece of advice to create homemade beverages? In what context it would be beneficial to use sugar beverages during exercise? Well, if they're gas beverages, the carbohydrate content is about 10 or 12%, a little bit high, according to what we said in terms of gastric emptying. Like, for example, in cycling, cyclists, the fact that they are consuming gas beverages, well, they do it not only because they like the flavor. That's one of the most important things that I was talking about before, but they have a little bit of caffeine that helps them feel well during the exercise. So this could be one useful scenario. The point is that in cycling, it is relatively easy, everything that has to do with gastric emptying, because it's not, I mean, the race is not the same. I mean, biomechanics is different. So it's easier to drink or to eat more things in cycling rather than when you're running or when you're swimming, of course. So this would be one of the scenarios. In this case, we would be missing sodium. As I told you, sodium
doesn't only stimulate that wish of drinking, but it can also play a role in the intestinal absorption. So there would be a lack of sodium. And well, homemade beverages. When I worked at the National Institute of Sport in Venezuela, and we had food service. When I started to learn about these topics, temperature, flavor, etc., we design beverages to put different beverages at the food service, so that athletes that lived downtown could come around, could fill their bottles to bring them to the training session, and that practice was totally successful because we were not only improving the flavor, but we were also including sodium. So this, for you to see that if we're following a simple strategy, we can increase that intake. Sorry. So for a homemade beverage, you need, for example, warm water with 6 spoons of sugar. That would be carbohydrates. You can add a small spoon, a teaspoon of salt to that beverage. So you'd have sodium and chlorine, and you could add flavor, for example, of orange or lemon, in order to give flavor and to add potassium. That is what fruits have. So that would be, yeah, well, we should dissolve everything in warm water, and to complete that with the remaining litters. And well, of course, you try to offer that cold at around 15 degrees Celsius, because when it is at room temperature, it doesn't taste very well. So it's important to take these details into account when we don't have resources, but these elements are very helpful for athletes to hydrate better.
Okay, just a couple more questions. How long after exercising do you have to drink to make up for the sweat you've lost? Well, ideally, actually, you should drink during exercising. You should eat, in fact, as soon as possible after the exercise, especially if you're an athlete who trains twice a day. If you train in the morning, then after you do that, then you have to both recover and prepare for the next training session, and then monitor your hydration throughout the day. When you urinate, make sure that well, you monitor the color, because if the urine is clear, then it means you're well hydrated. If it isn't, then it means you need more liquid. So drink before and after training, and on a day that you don't train, drink regularly throughout the day. Athletes are athletes all the time when they don't train, so we always need to take proper care of what we eat and what we drink. But the brief answer, the short answer to that, as soon as you can after exercise. Jose Antonio asks whether you would recommend consuming both maltodextrin and fructose as carb sources. Well, when you use different sources of carbs, glucose and fructose, for example, you use different gut pathways, which makes it easier to absorb both liquids and carbs. So yes, it always helps to use two different groups of uh, carbohydrates. Yes, when we need more than 90 grams per hour, of course, that's more difficult. But yes, ideally, we'll make a note of that. And then last question, because we're doing quite well on time. Could swimmers sweat more or less depending on where they're swimming, meaning in fresh water or at the pool or in the sea, in salty water? That's a good question. Yes, sweating can vary in swimmers. I don't know if the chemical composition of the water can affect how much they sweat, but the temperature of the water certainly does. So it's important that when we measure the sweating rate for runners or race walkers, we always factor in the temperature of where they're training, and you could probably do that for swimmers, depending on the temperature of the water they're training in. But I don't know if the chemical composition can have an impact as well. Meaning, I don't know if training in different aquatic environments can lead to a different sweating rate. I don't know. Very good. Well, Pedro, thank you. Thank you very much for sharing with us your knowledge for the past hour. We look forward to seeing you again soon, either online or in person. Thank you. Thank you all very much. Have a great day. I hope I've contributed to making you even more confused than you were before. Thank you, Pedro. Bye bye.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen a primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional, y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que de las mejores opciones que puedo elegir estar en el Real Madrid, solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
Yo creo que la llave para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Vale. Estamos de vuelta. Ahora
Okay, we're back. Now with us we have Dr. Maria Martinez Ferran. She'll be talking to us about antioxidant vitamin supplements, an update on the current scientific literature. She's an expert researcher in sports nutrition, director of the Masters in Nutrition and Dietetics for Sports, a professor of the Isabel I University. Over to you, Maria. Guys, everyone, if you want to ask questions, please feel free to use our chat, and I look forward to seeing you again later. Hello again, good morning. My name is Maria. Thank you very much for inviting me to take part in this very, very interesting round table to share my knowledge with you. I also actually studied the European University's Masters in Sports Nutrition. It helped me a great deal. And then I went on to do a PhD on antioxidants in particular, specializing, in fact, in vitamins. So today I'd like to talk to you about the current state of the art in literature regarding these very important molecules in sport. So I'll be talking about oxidative damage, antioxidant systems to begin with. Then I'll be filling you in on antioxidants in sports. We'll be going back through the available evidence, and then key takeaways, key messages. Let's begin with the first point. Now, one thing that's important to bear in mind is that multiple chemical reactions within the cells create reactive kinds of oxygens and nitrogen. A lot of them are free radicals. A free radical is a radical where one electron is missing. What are these main reactive species? Well, for oxygen, we have superoxide. It is a derivative of molecular oxygen, and it's not highly reactive. But then we also have oxygen peroxide, which is it plays a very important role in D2 signaling within the cells. And then we have hydroxyl, another free radicals that is highly reactive. Now, for nitrogen, we have an important derivative, uh, nitric oxide, which I'm sure you're familiar with. When you drink beetroot juice, for example, you're taking in quite a lot of this compound, which is useful for a number of purposes in our body. This is a free radical, which doesn't mean it's a bad thing. It's actually got antioxidant properties, but in high quantities, it can become reactive, and it can create nitrite oxide, which is even more reactive. Anyway, so there are some highly reactive compounds, but our body also has an antioxidant systems, which under normal circumstances prevents anything bad to happen. But when there's too many highly reactive compounds, then we can create oxidative damage. Now, where do these highly reactive compounds come from? There are endogenic sources, mitochondria, but there are also exogenic sources. Smoking, cigarettes contain a lot of reactive species. Certain drugs or alcohol also contain it, and they increase the production of reactive compounds like these ones. Pollution does as well, sun exposure as well. Now, when the balance between our antioxidants and highly reactive compounds is tipped in favor of the oxidative compounds, it can lead to damage. It can damage our DNA, for example, even, which in the long run can lead to neurodegenerative diseases, cancer, diabetes, cardiovascular diseases, respiratory diseases. It plays a very important role in our health, this system. So let's move on to the next part that I'd like to talk to you about, the antioxidant system. Depending on cellular physiology, we can classify our antioxidant systems into primary, secondary, and tertiary antioxidants. Primary antioxidants are fundamental because they stop new reactive species from being engendered. For example, superoxides can be easily turned by our system into peroxide, which we saw earlier. Then we have catalase and peroxidase glutation, which are absolutely essential. These are all primary antioxidants, but we also have non-enzyme protectors, also known as secondary antioxidants, which prevent highly reactive compounds from attacking our body. We have glutation, for example, and two very important vitamins that we're all familiar with, vitamin E and vitamin C. And finally, we've got tertiary antioxidants, which are in charge of repairing damaged cells. For example, we have the repairing enzymes of our DNA. So these are found in our mitochondria, in the cells, within the blood, outside of it even, and they provide full protection to our bodies. But from the nutritional point of view, the most interesting distinction is between exogenic and endogenic substances. Endogenic substances are generated by our own body. So we have glutation peroxidase, catalase, SOD, glutathione, which is the main endogenic non-enzymatic antioxidants, but then we also have exogenic antioxidants, which we acquire through diet and supplements. So vitamin C, vitamin E, acetylcysteine, a number of different compounds. Through supplements, furthermore, we can obtain many, many more antioxidants, although many of them won't actually get to the spot in our body where they're supposed to take action. But at the pharmacy, you can get all sorts of them anyway. And it can actually be a little risky because, as you will see over the next few slides, some things do more damage than they help. Anyway, vitamin C and vitamin E. Vitamin C is soluble in water and it can be found in intra and extracellular cellular fluids. It's found in high concentrations in our body and it's a very, very powerful antioxidant. Main sources are fruit, citrus fruits especially, and many different vegetables. And then vitamin E is a liposoluble vitamin. So it can be found in fats in our liver as well, and it can be obtained by vegetable oils, nuts, and seeds. It's got 8 structures, the most important part of which is alpha tocopherol. Vitamin E prevents lipoperoxidation from happening, which is a very, very harmful process. And so it's an important vitamin, this one. And it acts in synergy with itself, meaning it's used in in its very own recycling process, meaning it helps itself help the body. So this is a great vitamin. After the short introduction, let's have a look at antioxidants in sports and let's take a look at the available scientific evidence we currently have. When did we find out that free radicals can be found in muscle? In 1950, more or less. In 1980, 30 years later, we found out that exercise can engender free radicals and create oxidative damage, which is something that can, of course, damage muscles. In the early 2000s, we also found out that reactive species play a very important role in exercise adaptation. They play a very important role in cell signaling. Let's have a look at where these reactive compounds are produced. We all know that exercise, of course, is an extremely healthy practice, but repeated contraction of our muscles, repeated flexing of our muscles can engender a free radical, which in turn can damage our muscles. Where do they come from? They mostly come from complexes 1 and 3 of mitochondria. Some of these sugars that are produced become free radicals. For a long time, we thought that it was mostly high resistance exercise which produced free radicals, but there are other kinds as well. And it depends on the enzyme, for example. An ADPH oxidase, for example, which is found in a number of different places in our body, can free up and generate a lot of highly reactive compounds to protect us, to stave off other pathogens, in fact. But nevertheless, phospholipase 2 process can also engender free radicals. This process is aimed at creating hyaluronic acid, but it can create free radicals as well. And then we have another interesting compound, nitric oxide, which is produced in high quantities during exercise. Another interesting source is xanthine oxidase. What is this enzyme? What it does is it transforms hypoxanthine into uric acid, and while it does that, it creates a lot of free radicals. But where does hypoxanthine come from? We do know that exercise create APT, and high intensity exercise immensely increases ATP usage rate, which in turn leads to high ANP. ANP is one of the base products that are metabolized by our body, and this creates hypoxanthine. And so it's a compound that's freed up in high quantities during high intensity exercise. This is a bit of an overview of the main reactive species, of the main reactive compounds during exercise. This doesn't have to be all bad necessarily, mind you. So, over time, more and more studies have been conducted into free radicals, and people found out, of course, that they can lead to muscle damage, oxidative damage. And so, over the years, people have started recommending that we take supplements to reduce oxidative damage, to reduce fatigue, to improve performance, and so on and so forth. This is something that actually nowadays a lot of people do. A lot of people take supplements to prevent this damage. But let's see if that's the right thing to do. With this study carried out in 2024, a number of different people took part in this study from Spain, cyclists, swimmers, and so on and so forth. And a high percentage of them use supplements. In the case of swimmers and runners, fewer people do. But anyway, supplements are generally speaking widely used, so it's important to know pros and cons.
So I'd like to make a remark here, and now with the AI, for example, by a lot of leads, etc., they are asking for the sports planning or nutritional recommendations to ChatGPT, especially if they have no means, or in case of amateur athletes. What kind of antioxidatives could I have? So we can see some substances here with their doses. So if we ask it if it's good for muscle damage, it will say that it's good to have all these supplements. I want to highlight that it's very important to go to a professional, okay? To go to a sports nutritionist or to a professional as regards the training session, because otherwise you can find these problems. Or could, for example, if we make a Google research, we can find the same problems. So, what does the evidences tell us? What do the evidences tell us? The hypothesis of muscle damage. We know that physical activity, it's obvious that it creates a muscle damage. They could be assessed through biomarkers like creatine kinase, an indirect marker of muscle damage because it's released partially because of an increase of permeability of the plasmatic membrane. And we see that reactive species, as I've said before, will attack the membrane lipids and they could create an increase of permeability. So one of the hypotheses have to do with antioxidative vitamins is that if we supplement, for example, vitamin E and C that have an influence on the recycling, maybe we can stop this process and we can avoid this increase of muscle damage. But what do studies say? Does it really reduce the muscle damage caused by exercise? In year 2020, we analyzed a systematic review with the goal of analyzing whether acute or chronic supplementation with vitamin C or E produce that muscle damage, assessed through creatine kinase in amateur professional athletes, sedentary people, or people that were physically active. And 6 studies out of 21, 20% confirmed that supplementation with vitamin C or E reduced muscle damage. And 72 studies didn't find any difference between placebo or vitamins in muscle damage. So what protocol did studies that found benefits followed? So some of them used different acute vitamin C that shown to reduce eccentric exercise damage in professional basketball players. And another study used vitamin E, acute vitamin E, with an exercise session in hypoxia in active subjects. We have several researchers with supplementation protocols that are chronic supplementation. Vitamin E, for example, chronic vitamin E reduced muscle damage in the power activity in resistance training in active subjects and in cycling for 5 months in trained subjects. And the combined supplementation of vitamin C and E chronically reduced the muscle damage during the preseason in football players. I would like to highlight that the doses were over the recommended daily intakes. The daily intake of vitamin C are around 90 milligrams in men and 75 milligrams in women, and vitamin E around 15 milligrams if I'm not mistaken. So imagine, vast majority of studies used between 500 and 1,000 milligrams of vitamin C and 200 milligrams of vitamin E, so high doses. So if we focus on the researchers that use acute supplementation, there were two, another one with vitamin C and another one with E, suggests that 2 out of 5 studies showed a benefit in the muscle damage, but specific conditions like eccentric or hypoxia excessive bars. But these are just 5 researchers. It's a very reduced number to make a recommendation. Okay, so we saw that there was no acute study that used vitamin C or E combined, because there's only one hydrolyzed study with vitamin E and another 4 with vitamin C. So we thought about conducting a randomized double-blind research in 18 men between 39 and 58 years old. To half of them, we gave them vitamin C, to the other half, vitamin E or placebo. And then something important is that we set a standardized intake that covered the recommended intake of these vitamins and following the recommendations for training and resistance. Since we saw that many researchers that were included in the systematic review did not control for example, the intake, they said that the participants had to follow their usual diet, or they didn't register what they were consuming or not. We didn't know whether they were having the daily intake that was recommended. Vitamin C, for example, has a benefit because it is covering the daily intake, or maybe he's making a higher consumption. So that's something important that should be considered. So what did we do? As an important part is that nutrition was planned by me, that I'm a sports nutritionist, and the training the training part was conceived by people that are expert in that. So there was a blood extraction by nurses to assess the creatine kinase. So we saw different performance tests. They took the supplementation and a standardized breakfast based on carbohydrates. 2 hours later, they held a training session, a resistance session, with a continuous intensity and another part of sprints. And when they were over, we assessed the effort perception with a scale. We received that assessment again, and 24 hours later, we took blood samples again to analyze the muscle damage, since the creatine kinase had its peak after 24 hours, and we have a jump-based performance, and we see if there were muscle soreness. So we see that there was no significant difference after 24 hours, and we don't see important differences in group per time. So the vitamins did not prevent these muscle damage. We didn't see a difference in performance in terms of jumps, in the effort perception, or in muscle pain. Okay, so we've talked about supplementation, but what happens with chronic supplementation? Because there were some studies that were seeing a benefit there. So if we go back to our systematic review, 4 out of 16 studies, 25% see that chronic supplementation has a reduction of muscle damage. 3 out of 7 studies when supplementing with vitamin E, and 1 out of 9 studies with combined supplementation with vitamin C and E. This suggests that maybe the supplementation with vitamin E could be beneficial, because 3 out of 7 studies, almost half of it, are beneficial. And this is confirmed by a meta-analysis 2 years ago that concludes that supplementation with vitamin E reduces muscle damage assessed with creatine kinase. So every study, including this meta-analysis, with the exception of one, uses chronic supplementation, and the one that used acute supplementation is the one that had that impact on the hypoxia exercise. But what happens with chronic supplementation? This is what we'll see in a minute. Basically, chronic supplementation can inhibit some adaptations for the training session. I will explain that later in further detail. So we've seen the muscle damage. We've seen a variable that could be reduced, but we don't have enough evidence. So the delayed onset muscle soreness, that feeling of rigidity that intensifies 24 hours after the exercise. So out of this variable, we did another systematic review according to Torre et al. From 2021. Every research that I'm participating or where I'm the main author are available on my ResearchGate, so you can access them. So out of 14 studies, just 3 reported benefits, but all of them were using chronic supplementation. So maybe we will have benefits, but we will have other negative effects mainly. So as I said before, in our randomized control test, we didn't find any benefits. And this concludes that the investigation with different antioxidants, not only with vitamin C or vitamin E, doesn't mean an improvement in delayed onset muscle soreness. So they are in line with a Cochrane review. So we'll see the third variable, that is the performance improvement. In our systematic review, the first one that we've seen, we analyzed secondarily this performance. And we said that no study has found an improvement in performance. We didn't see that either in our randomized study, and we haven't seen it in any other author by Martin Ferran or Higgins and colleagues. We see that the antioxidants, supplemented antioxidants benefits are not very important. So, as I was saying before, at the end of the 90s and the beginning of the years 2000, there was a paradigm shift in terms of the oxygen and nitrogen species reaction. We see that these are important signals for the exercise adaptation. I mean, the redox signaling is involved in many cell paths. So the high supplementation doses could inhibit these adaptations to the training sessions. This was started the first time in 2008 by Dr. Gomez Cabrera, and we'll see some of the conclusions they drew. So what are these training adaptations? These are changes in the structure and function of different organs changes in the structure of functions of tissues or different organs that happen because of the training session in order to adapt better to future stimuli. So what is an adaptation, for example, for a power session based on the muscle increase? Or in the case of a resistance training, we could talk of an improvement in the oxidative performance. This would have to do with mitochondrial biogenesis. So if we focus on resistance training, we see that a paramount adaptation to this resistance training would be the increase of our endogenous antioxidant system. I mean, the exercise is the most important antioxidant, and it creates a stimulus for our endogenous antioxidant system to improve. And in this signaling, the oxygen and nitrogen species, relative species will be involved. So if we supplement with antioxidants, these signals will be mitigated, and thus will affect these adaptations, will produce more negative effects rather than benefits. Another adaptation will be the mitochondrial biogenesis. That is a paramount adaptation for the resistance training, since it improves our oxidative metabolism. And these ERON are involved in this adaptation. So supplementation could be negative for the increase of the resistance performance. And we can see this. Despite this, many resistance athletes, as we saw with the cyclists that we were seeing before, are consuming vitamin C when it could be having a negative effect. So let's move on to power training. Many athletes are training this as a complement to their main sport, and sometimes they're looking for that increase in strength or muscle mass, that hypertrophy. What happens if we supplement with vitamin C and E if we are focusing on strength? This was analyzed in 2020 on this systematic review and meta-analysis by Dutra and others, and determined a great heterogeneity of individual researches. That is, there's a heterogeneity in terms of supplementation dose with vitamins, in terms of population, in terms of older or younger participants, in terms of methods to evaluate hypertrophy or strength or in training sessions. So it's very difficult in these cases to draw conclusions that have a foundation. So in the vast majority of studies, this systematic review, I think there were like 7 studies, doesn't find any benefit or any negative effect, but they said that they can be negative, they can jeopardize the performance. So it's quite heterogeneous. So we'll focus on the studies that were made in or among young population. Okay, so 2 of these researchers had an eccentric training protocol with 2 weekly sessions for 4 weeks with an isokinetic dynamometer. There are no differences between groups in the strength gain, and they didn't consider hypertrophy. So this research had traditional strength training with 4 weekly sessions for 10 weeks. So they see a higher improvement in terms of strength in the upper limbs, although there are no differences in muscle mass. They see mitigation in the cell signaling linked to hypertrophy in the group that was supplemented with vitamins, suggesting a negative effect. As we saw the need of setting another study following the Paulson training method, we set another double-blind study with 23 men. We started with 32, but in the end, it was a protocol that requested great level of adherence, and we lost participants, and because it was just after the pandemic, and some participants in the end had COVID and they had to be locked down. So we had a 10-week training session with 4 sessions a week, 2 sessions focused on upper limbs, and 2 sessions for the lower limbs. We supplemented them with C and E vitamins or placebo, 1,000 or 235 milligrams, and they followed a planned diet by me, focused on covering the RDAs of vitamin C and E. And the diet followed the recommendations based on strength sessions focused on improving that hypertrophy. So we had calorie superabundance in surplus in the training sessions, and in the days that were no training session, the calorie intake was lower based on if there was a training session or not. And how did we assess strength? We performed a test on push-ups, and we saw what was the maximum amount of weight they could lift, sorry, and we determined the maximum strength with a dynamometer, with a dual absorptiometry of X-ray. It's quite accurate. It divides the body in 3 compartments: bones, fat, and muscles. Well, basically what it measures would be the soft tissue that is fat-free. So what did we see? Okay, as regards the fat-free soft tissue, we saw that only the placebo group increased the kilograms of this tissue in the dominant arm and in the non-dominant arm and in the upper limbs in general. For example, in the trunk, legs, etc., there was no difference. But that was a problem when the placebo group just was improving that significantly. Same happens with that gripping strength that was only increased in the placebo group. As regards strength, both groups increased the number of repetitions in squat and number of repetitions in maximum strength, the maximum repetition in push-ups. So they were training for 10 weeks with a very demanding session, but we saw a substantial effect with a maximum repetition of push-ups. That effect was a statistical analysis that suggested that placebo group had a higher increase of strength. So we see that vitamins here will have a negative impact. And what are the mechanisms that are linked to this? So on this Margaret Ellis research, we can find different results based on other researches. And we have the oxide radical that came from molecular oxygen that entails many processes. It would be the mother free radical, and it becomes into oxygen peroxide by the peroxidase dismutase. So it is very clear, and it has a very important impact in cell regulation. So this hydrogen peroxide will increase the phosphorylation of different components, this receptor or this kinase, and this will entail an increase or an activation of mTOR pathways, empowerment to increase the protein synthesis, and on the long run, it will mean that when the synthesis is higher than degradation, it will mean and skeletal muscle hypertrophy. And on the other hand, we see that peroxynitrite, that was the one produced when the peroxide was reacting with nitric oxide, will create different cascades that will increase the pathway. And some of these researchers have seen that supplementation with antioxidants mitigates this phosphorylation, and this means a lower protein synthesis. So in the end, we see that there are mechanisms that are involved in all this process, right? And what about strength? So studies suggest that we need an optimal redox state for the maximum strength reduction. And when we have low levels of reactive substances, for example, if we supplement that with antioxidants, we won't produce that maximum strength. So the opposite would be negative to a very high content of reactive species, because it could create an oxidative damage, as we saw at the beginning. We need a balance. So if we train strength, resistance, we will alter our optimal redox state, and we'll go to the reduction phase, and this will alter signaling, and it can mean a mitigation of the adaptations for the training session. And as a whole, supplementation can be negative for adaptations, and we don't have enough evidence that it improves muscle damage, and there's no evidence that it improves performance. Here, I'd like to indicate what we see sometimes. There's a ranking based on the level of evidence of supplements, and we see that Group B are the ones that have an emerging evidence that they could be beneficial, although there's no enough evidence to be in Group A, and Group C would be the one that evidence proves that they have no effect, or maybe there's no enough evidence to have an opinion about it. And what does it tell us about vitamin C? Well, you see that it integrates non-processed food that contribute vitamin C, and only when a sport nutritionist tell us we could consume acute supplementation of vitamin C between 500 and 1,000 milligrams. But for what? There's no evidence about oxidative damage. It's not for that. It is to support immune system during a disease if we're training intensely. And this is what has a moderate evidence to be beneficial for the immune system when we're ill. And what about vitamin C? It says that it shouldn't be supplemented forever, and it requires more evidence, because the use of acute vitamin E doesn't have many researches about it. There's no evidence yet. And when we're looking for immediate retention of performance, and we are not jeopardizing the training adaptation. So, well, this figure coming from an stage infography is very important. I'm sure that many of you know it, and if not, you have it here. Many athletes are starting their diet part with supplements. And the last thing would be to be concerned about balanced diet. We should get started from here because it will cover almost everything. And when we require it, if we require it, we could use supplements. So once it is offset, it will cover the requirements of vitamin C, D, and other antioxidants. So it is what we have to do to start by here. And if necessary, we could go to professionals that could help us with supplementation. And besides, for example, strawberry and kiwi, not they don't only contribute vitamin C, but also hydration, fibers, other polyphenols that have many of the benefits than using supplementation, just a pill that only has vitamin C. And we'll move to the key points, to the takeaways, just a brief summary of everything we've seen. Well, first and foremost, the reactive species of oxygen and nitrogen are produced normally in all of us, and it's okay because we have a system that keeps balance. In fact, these reactive species participate in cell signaling of our body. When the production is very high, there could be an oxidative damage, and at current level, on a long run, it could be bad. So do you have an evidence of supplementing vitamin C and need to prevent muscle damage or to improve performance? No, there's not. And the few evidences point out that some conditions, like for example eccentric exercise, where the muscle damage is increased, could be beneficial for it. I mean, but currently we don't have enough evidence to supplement. And if we want to supplement it, always active supplementation, because vitamin C, if we want to look for as benefit of the immune system during a disease. Chronic supplementation should be avoided in high doses of vitamin C and E, since it could jeopardize the adaptations of strength and resistance strengths. And what's paramount, we should follow a diet that is rich in fruit and vegetables that covers the antioxidant vitamins recommendations, and of course, well, seeds, dried fruits, high quality oils, because this will give us the antioxidant vitamins like vitamin E, that's an antioxidant vitamin, and they supplement a great amount of polyphenols. And a key message, of course, exercise is the best antioxidant. The exercise will increase and will improve our endogenous antioxidant system. So let's imagine an athlete or someone, the sedentary person that starts to train during the first weeks. This person will produce more reactive species and they will have a strong antioxidant system. We supplement this person? No, because otherwise we'll inhibit these signals to create this antioxidant system naturally in our body. And this would be it. Well, here you can find the bibliography for this presentation. And thank you very much for your attention. And you have my email on the screen. I'm fully available for any kind of question. Thank you. Thank you very much, Maria. Amazing. So we have one question here by Sergio Torres. It says, well, besides vitamin C and vitamin E, the consumption of an acetylcysteine could be negative when adapting training, other strength training, or resistance training. Okay, Sergio, I haven't read about this compound, but I think that vitamins are shared, and if we use high dose of antioxidant system, it will create the same results. In fact, with polyphenols at high dose, it could happen. So we'll need to see if there's a specific research about this compound that you've mentioned, and acetylcysteine. Sergio is asking, the antioxidant consumption could be useful in competition days where the adaptation development is not a priority, but recovery. Well, let's see if I've understood the question. We've seen that the evidence shows that there are just researches that show this, but if it is used, will facilitate recovery. Let's see, our athlete thinks that this is offering a benefit. So if we're just taking that at the competition, we won't have an influence on these adaptations. So we have, if we take it on the competition day, well, we don't know whether we're going to have a benefit or not, but at least we won't affect these adaptations. Yeah, totally agree. So Anna Martin asks, so would it be better if you need to take antioxidants, if you need to support other aspects, for example, to take the days that we can have them, or how can we do it? Oh, if we take vitamin C during a disease, we've seen that there's an evidence that we'll take what has been recommended. It will be negative for health, for adaptation, sorry. To take them the day we do not train, well, the changes that happen during the exercise day won't only happen during these days. They will be kept in 24, 48 hours. So same will happen. We need to look for the fact that, well, with a diet, we're covering needs. An athlete will have the need of having more antioxidant vitamins, but they will consume more calories. So we'll have more antioxidants too. So this is what we want to look for. For example, many people, many athletes are taking vitamin supplements, but do they need it, or are they covering the needs? The most important thing would go to a dietist, to a nutritionist that completes the nutrition. And we, in these cases, we do not require an antioxidant. For example, iron. If there was a lack of iron, a supplement would be, of course, recommended under medical supervision, or other vitamins or minerals. Okay, amazing. So I think we have no more questions. Thank you very much, Maria. Your talk has been very interesting. It is something that has been tackled in the last years. And of course, we need to keep on investigating because we don't know everything. Of course, we always need more research. So yeah, that's a conclusion. So thank you very much, Maria. And well, guys, now we have the next talk by Dr. Maureen. He will speak about spring spine mechanics and managing ischial-tibial lesions. He's an expert in sport recovery. He is a professor at the University of Saint-Étienne in France. He's French. He's the professor, he's a teacher and the high performance master of the Real Madrid School. And now we play the video and we continue with his connection.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen a primer equipo, sino que también formamos personas.
Formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores para que lleguen a primer equipo, sino que también formamos personas.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que de las mejores opciones que puedo elegir estar en el Real Madrid. Solo la marca Real Madrid ya te abre muchísimas puertas.
Campeones se pueden formar en todos los aspectos de la vida. Lo importante es saber ser un campeón.
Cuando quieres mejorar cada día, no estar satisfecho con lo que hiciste ayer, creo que para mí eso es lo que te hace ganar día a día.
Realmente lo que más se aprende es a establecer nuevos contactos. Eso es imprescindible para los proyectos profesionales.
Pero nuestro espíritu ganador nos caracteriza, y nos caracteriza no porque lo decimos nosotros, sino porque nos reconocen los demás.
Yo creo que la llave para tener éxito es hacer algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Hola, buenos días, good morning, good afternoon everyone. I am Professor J.B. Morin from the University of Saint-Étienne in France, and I'm going to present you today about sprint mechanics and hamstring injuries management. So if you want to connect with me and if you want to follow our works, you just log to the Instagram, Twitter or my website to have more information and to contact me. So I have no conflict of interest. I'm going to talk and to present about some technologies, but I am not economically related to the development of these techs. So first, to explain you the last 10 years of work we have done in this area, it's a collaboration between three different parts. One, of course, is performance, coaching and biomechanics and the works of Johan Latti, who was a PhD student I've supervised. The second one is medicine, with the doctor, Professor Pascal Edouard, who is a specialist in sports injuries and hamstring injuries. And one is physiotherapy with Jordan Mendiguccia. And I want to say that what's very important in the clubs where some good work is done around injuries is that these three different departments collaborate a lot, and this is why eventually you have more performance. So everything started 10 years ago, 12 years ago with the paper of Jordan Mendiguccia. He was asking that question, are we heading in the right direction? Because he was seeing more and more research on the strength capacity of the muscle and a focus on the muscle architecture and strength capacity. And he was asking, well, maybe we should take more into account the mechanism of injury that is very often sprinting and everything that is related to the strain in the muscle during sprinting. And then about 10 years later, that was 2 years ago, we've published an editorial where we summarize our thoughts, and I'm going to discuss that today, around sprinting as a key piece in the hamstring injury puzzle. So first, let's start with the context, and to remind you a bit of a context around hamstring injuries, that's very important. After 30 years of research, we observed that the problem is not solved, and that numbers are even have a tendency to increase. So you can see that in insurance reports. So this one was done over the 5 big leagues of football in Europe. And you see that the hamstring injuries are still a very frequent type of injury and a very costly type of injury. And there has been a lot of research, but these results tend to be always the same. So maybe there is nothing we can do, and maybe the players play too much and the fixtures, the organization of football has too much strain. But we need to remember that in some clubs, there is some good work that is been done, okay? So the next thing is, here we have 2 recent reviews of literature. One is following the elite clubs in the UEFA, and they show exactly the same thing, that the tendency of injury frequency is increasing, and at least it is not clearly decreasing. And what is interesting is that in these 2 papers, when the authors discuss why is it so, they both have a very little piece of explanation where they say that basically, very likely, the players do not apply some measures that have been shown to be efficient to prevent injuries, that is strengthening the muscle. And so their conclusion is that there has been some studies showing that strengthening the hamstrings decrease the risk of injury, and people do not do enough of strengthening exercise. But the problem is that this is a focus on the capacity of the muscle. And of course, in many clubs, people know that we need to strengthen the muscle, and people actually do muscle strengthening. So maybe that's not exactly the only piece of the puzzle. So just a quick summary of the literature around hamstring injuries and force capacity. First, clearly, it is not a factor that is powerful enough to predict injuries. So there has been a lot of meta-analysis and a lot of cohort studies in the last years showing that the force of the muscle, if you assess it in isokinetic, for example, testing, or in the Nordic hamstring exercise tests, it is not a predictive factor. It means that some athletes with a low force capability will be injured, but also that some athletes with a high force capability will be injured as well. And you mix that into a statistical analysis and a meta-analysis, and you end up with no clear results. So there has been some meta-analysis, there has been some cohort studies, and the last one was presented by Opar and his colleagues 2 or 3 years ago, and they show that the Nordic hamstring exercise strength that you measure pre-season is not statistically associated with a future risk of hamstring injury. So it means that it is a factor. I don't say it's not a factor. It is a factor, but it's not the only one. Now, in terms of prevention, there has been some studies showing that if you increase the strength of the hamstrings, you decrease the risk of injuries. And there has been some reviews of literature showing that. And maybe the most famous one is the one by Nicole van Dijk and his colleagues. But the problem is that in this study, there has been a couple of methodological limitations pointed out by an Italian author, Franco Impellizzeri, that shows that, for example, when the title says if you include the Nordic hamstring, you will divide the risk by 50%, it's a big title, it's a bold title. And many staffs have observed that it was not the case. Between the moment they did not do it and the moment they did it, they did not see 50% less injuries. But the problem is that in this study, they include, for example, some multi-modal, multi-exercise programs, such as the FIFA 11+. And this program has 11 exercises and the Nordic hamstrings. But they attribute the results of the program to the Nordic hamstring exercise only. So Franco Impellizzeri has done this systematic review again with very likely a more robust methodology, and the conclusions are not the same. The conclusions are there is no clear statistical difference between using that exercise and not using it. So it just means that very likely at a group level, it is not the only measure, and it is not only about the capacity of the muscle. And so what you need to understand is that in some clubs, there is an improvement in the prevention. So it means that studies, academic studies, publish some group tendencies, but in some isolated clubs, some job is done correctly. And I am very friends with people in some staffs, for example, in Monaco in France or in Osasuna in Spain, and they have a clear reduction in hamstring injuries during the recent year. So their example is opposite to the big tendency, but it means that in these clubs, the job is done correctly. And it means that they don't only focus on the capacity of the muscle, the capacity of force of the players, always stronger with longer fascicles, but they also try to consider reducing the strain, the mechanical strain in the hamstrings. How do you do that? First, you want to be that you don't want to be that white man here, trying to remove water from the boat, always improving strength, where the problem is not exactly that. The problem is something else. So what we mean by strain is a macroscopic type of strain. This is the dose, the exposure to high-speed running. This is what brings strain in the muscles. Of course, if you stop sprinting or if you don't run fast, then you will have less strain in the hamstrings. But during the games, you need to run fast and you need to sprint a lot. The second type of strain is the microscopic strain. That is the mechanical strain in the hamstrings during running. So for example, if you manage my sprint exposure and I have 200 meters per week above 90% of my maximum velocity, maybe if another player on the team has the same exposure, they don't have the same strain because their mechanics induce a different strain in the muscle. And so it means that even if we have the same macroscopic strain, maybe we don't have the same microscopic strain, and overall we don't have the same risk. This is exactly what I'm going to develop today. So let's go to the introduction and talk a bit about sprint mechanics and what we are going to assess and focus on. So this is going to be a very short part because it would be another lecture, but this is just to summarize things. So if we look at the big picture of sprint mechanics and performance, we could say that, as you can see here, running fast, accelerating is producing force and transmitting that force to the ground with effectiveness. So if you want to assess correctly the sprint mechanics of a player or an athlete, you need to measure two things. You need to measure the kinetics, that is the forces applied to the ground. We call that the ground reaction force, how much force the athlete is able to produce to the ground. And also, you need to be able to measure the kinematics, that is the segment pattern, the sprint pattern or the sprint form. And as we will see, both of these factors are likely related to the strain in the hamstring muscles. So how are you going to organize the measurements of the kinetics? That's possible, but it's very, very limited in terms of possibilities. First, you need to find an instrumented treadmill that allows you to sprint and record the forces at the same time. There's only two like that in the world. I'm very happy that my lab has such a treadmill. Or you can find some places in the world where you have some tracks that include force plates over a long distance to be able to capture, to measure the ground reaction force correctly. And I'm also very lucky because my lab also has such a force plate system, as you can see here in the National Institute of Sports in Paris. But this is not very practical, and it's a bit frustrating for coaches because it's important to measure the force output of the athletes, but you cannot really measure it. So this is why we have proposed a simple method to calculate the ground reaction force during sprint acceleration based on the laws of motion and based on some position or speed measurement. So everything is based on a very simple model that says that acceleration from 0 to maximum speed in humans it follows an exponential function. This has been described more than a century ago, and this has been described in many papers, and this is systematically observed. You observe this exponential model in the world record of Usain Bolt, in football players, in track and field athletes. You observe that in young people, such as my son here when he was 3 years old, but you observe that also in very old people. This is a 96-year-old sprinter. So based on that model that is really systematic and totally systematically observed, we calculate the acceleration and we calculate, knowing the body mass, the force output that has been produced. And so there has been two studies validating this model. One in 2016 using multiple sprints to compare to a force plate gold reference data, and a second one in 2019 where we compared the data during a single sprint trial with these wonderful 50-meter force plate systems that is in a Japanese laboratory. And so the results are clear. The method is valid. If it's used correctly and if the measurements are used correctly, you can even calculate things using simple devices such as GPS or the application MySprint. And again, if the input of the method are measured accurately, then the outputs, and especially the force output, are measured correctly. Now let's talk about the sprint kinematics and the running pattern. So if you want to assess the running pattern, the main solution, the gold standard in laboratories, is to have multiple camera system and to quantify the 3D motion capture and the 3D mechanics. So this is very, very, very costly, and this is very difficult in terms of time and analysis. But you have many studies showing this, and we did a study with Jordan Mendiguccia, measuring the kinematics of the entire body, the trunk, the pelvis, the arms, the thighs, and so on, based on multiple camera systems. But again, this is not easy. So as a coach, as a physiotherapist, as a practitioner, what you can do is to use video systems such as your phone or a tablet or a GoPro camera, and to use a slow motion approach with 200 or 240 frames per second, and online software such as Kinovea that allow you to analyze the kinematics in the running plane of motion in a much more simple way. So for example here, by using a reference framework, Chris Brammer from UK published recently the Sprint Mechanics Assessment Score. That's a clinical score to assess sprint mechanics based on 2D motion analysis. And this score is now available in the My Jump Lab app. And basically in 2 minutes, you film someone in their maximum speed phase. You click on the screen to determine the main segments, and you have an idea of the angles, the positions, and you have a qualitative score. So of course, it will never be as accurate as a 3D motion capture system, but you maybe will never have access to a 3D motion capture system. So you can still analyze running technique with that. So in summary, the sprint acceleration performance depends on two things: being able to produce force, and we will see that the hamstrings contribute to producing force, but also being able to transmit that force effectively to the ground. And there is one thing missing in the picture, and to me, it's the main thing that is missing in many, many training environments, for example in football, is the fact that if you give me the best Formula One, I will not have a good performance because I am not used to drive a Formula One. So in sprinting, you also want to work and train the driver. The fact that we drive our muscles, and the fact that sprinting seems to be very easy, but it's a very complex task. So you need also to train in order to sprint better, which means do more sprints, and maybe do more sprints with a sub-maximum intensity, but a very, very high driving efficiency. So now let's go to this part where we will see that the hamstrings contribute to sprint mechanics and performance, and are also in danger in terms of mechanical strain when we run super fast. And maybe this is the paradox of hamstrings in sprinting. So there has been a lot of modeling studies, and there has been a couple of direct experiments, for example at my lab here, where the authors have shown that when we run faster, when we sprint, the mechanical contribution and the electrical activity of the hamstrings increase very, very fast. And so here in the Australian study that you see here, they show that when accelerating a lot, the contribution of the hip extensors is very, very high. Another study to show that has used a very interesting technique that is high density EMG. So you see here that we have EMG measurements all along the hamstring muscles. And Andras Hegi and his colleagues have shown that only during high-speed running, very high-speed running that was close to sprinting, the activity of the muscles is very, very high, even over the maximum isometric activity. So it means that if you run slow, or if you run at maximum aerobic speed, or if you do box-to-box runs, but not sprinting, the activity is not as intense as in sprinting. So this explains why the strain is so high in sprinting, but it also explains why you cannot avoid sprinting in training. If you want to prepare to the exact mechanical demands of your sport, then you have to sprint in training, and to do that consistently and regularly. The two last studies that clearly show the importance of the mechanical strain in the hamstrings in sprinting have been in 2006 by Thelen and colleagues. They did a modeling study based on the length of the muscles, and they show that when you go from 80% of your maximum speed that is high but not maximum, to 100% of your maximum speed, your running speed increases by only 20%, okay? So you go from almost maximum to maximum, but the mechanical strain, that is here the negative work in the hamstrings, increases by 40%. So it means that it is not linear, and this is very important. If you increase by 20% the speed, the strain doesn't increase by 20%, it doubles, it increases by 40%. So this is why, in my recommendation, I like to have people doing sprints close to the maximum running speed, but not exactly maximum running speed. And I think that 90% with a very good drive and a very good running technique is something very interesting. And this is also shown in a wonderful study by Italian colleagues, Cerroni and collaborators. They used here a direct measurement of the EMG, as you can see here with the EMG map that we have seen before, and they use that during actual maximum running speed. And what they show here, what you can see here in the red part of the graph, is that between 85% of maximum and the maximum speed, there is a huge difference at the end of the swing phase. That is, just before touching the ground, when there is both an extension of the knee that the hamstrings need to break and a maximum length. So when you add the length of the muscle and the tension, you increase the strain clearly. And this is why this is the moment in the sprint cycle where we observe the highest rate of injuries. So to summarize this part, and this is what we have detailed in this editorial in the British Journal of Sports Medicine, we think that sprinting is both a problem and a solution. A problem because, of course, we observe injuries during sprinting, not during low-speed running, but also a solution because we think that if it is well regulated, the stimulus is very important in order to protect the system. You know that's the principle of a vaccine. When you vaccine yourself, it means that you take the virus, the problem, in a very, very well regulated dose so that your body faces the problem better. This is exactly the same idea. And remember that you cannot replace the stimulus of sprinting in terms of EMG, length, speed, tension by using other types of exercises. So it is not replaceable. And for example, a study here shows in Gaelic football that the weekly exposure, that is the number of sprints that you do every week as a player, has a U-shaped relationship with the risk of injury. So one limitation of this study is that they just counted the number of sprints. They did not take the distance. And to me, this is a limitation because if I do 5 sprints of 10 meters above 90% of my maximum speed or 5 sprints of 20 meters, then my mechanical exposure is totally different. But anyway, if you see here on the right part of the graph, you see a very high risk of injury when you sprint too much, which is obvious, okay? If you sprint too much, if you play too much, then you will have muscle issues. But the interesting thing is that for the players who don't sprint enough, on the left part of the graph, you also have a very high risk. And so it means that you need to manage the amount of exposure to sprinting of the players to be almost sure that it will never be too high, but also that it will never be too low. There is like an optimum dose in sprinting. And believe me, the clubs where the results on sprint injuries are good, the clubs that I know, for example, the AS Monaco, since the last 2 seasons, they have reduced their injuries at the hamstrings drastically. They manage this sprint exposure very, very carefully. For example, at the end of a game, the substitutes who did not play, they run, which is pretty classical. But what is not classical is that they do some sprints. So they will do the average number of sprints that the other players have done during the game to be at the same level of exposure. So even if they did not play, at least their body was stimulated in terms of sprinting. And I think this is the good way to go. Always remember that our body is not made to sprint. We are not sprinting animals. We are pretty bad in terms of speed of running. If you take all the animals on Earth that sprint, we are pretty slow. And it means that anatomically, physiologically, our body is not made to sprint. And it means that if we sprint, we stimulate our body in a way that is not usual. For example, if you never sprint and you do 2 or 3 maximum acceleration, 2 days after you will have incredible DOMS, muscle pain, muscle soreness in the hamstrings. It means these muscles are not made for that. So in terms of prevention, we have to focus on building some hamstrings that are regularly stimulated on an individual basis. And so this is what we have developed in a multifactorial framework. The idea is that instead of saying everybody needs to work on the strength, everybody needs to work on the range of motion, we will address each player's puzzle differently. It means that we will take each player's values in the different tests, in different risk factors, and we will drive a program that is adapted to each player. So this is what was presented by Johan Latti for his PhD thesis. And I'm going to present you now the protocol and why we used some tests that include sprint mechanics. So this slide is a bit complex, but you will understand the philosophy. We have published the protocol in 2021, and we have published this year the randomized control trial. And if you read that paper, I will not have time to present here today that paper, but if you read the results of this protocol, you will see that some injuries metrics decrease. Not all of them, not all statistically, but some of them clearly decrease between the season of control, everybody does the same, and the season where we applied this framework in professional teams in Finland. So this framework is based on four screening categories. Lumbopelvic control, we will discuss that after. Range of motion, obviously. Strength of the posterior chain, obviously. And the sprint mechanical output of maximum force. So then we do some tests, we have some measures, and then we rank the players, and if they are good or bad at some tests, they have a different training program during the week. And as you can see here, there are some things that are not negotiable. They are all the same for all the players. That is high-speed sprinting, range of motion, manual therapy, and triceps work. We think that this is important for everyone. So why did we include the maximum force output? You remember, it's a kinetic factor, and it's the maximum force output that you can produce at the beginning of a sprint. We decided to add that F0 for two reasons. First, we observed that after an injury, after a rehabilitation process, the F0 was still low in injured players. So it means that maximum force output in sprinting for us describes the capability of the hamstrings to produce force in the very specific context of sprint acceleration. So we have many studies showing that. And then we did a prospective study. We followed a cohort of football and rugby players, and we saw that during the season, this is the study I'm talking about, during the season, we observed that the F0 factor was lower before an injury at the hamstring. So the preseason F0 had no statistical link with the risk of injury, which makes sense to me because it means that if you only assess the kinetics and F0 in sprinting in July, for example, in European football, then you have a very poor level of information in December, February or March, the year after, you understand? So you need to monitor that and you need to measure that regularly over time. And in that study, we show that statistically, if you measure F0 regularly during the season, the in-season F0 is related to the risk of hamstring injury. It means that for the players who had a lower F0 or a decrease in F0 during the season, their risk of injury in the weeks or the months after was higher. So it means that we added that to our screening protocol. The second category of mechanical factors that we have added to our protocol is about lumbopelvic control. So what is lumbopelvic control? It's just the way to describe how you control the movements of your trunk and your pelvis. So this is very easy to understand. If I move and I run and I have a low lumbopelvic control, then I will have some movements of the trunk and the pelvis that might be associated to the strain. In the opposite, if I have a good lumbopelvic control, then I will be able to better control my trunk movement and my pelvis movements, and maybe to limit the mechanical strain. So this is based on some literature where people show that the movement of the pelvis, so the contraction of some muscles that tilt the pelvis, is associated to the stretch in other muscles. So you see here, for example, the stretch in the biceps femoris is influenced by the contraction of other muscles that attach to the pelvis. And then we go back to anatomy, very basic descriptive and functional anatomy. The pelvic bone is a bone where many muscles attach. Some of them influence the movement of the trunk and the upper limbs, and some of them influence the movement of the legs. And so it means that when there is a trunk movement, there is very likely an influence on the pelvic position. And if you look at the insertion, the proximal insertion of the hamstrings, everything attaches to the ischiatic tuberosity that is a part of the pelvic bone. And so the thinking is very logical. If you have a movement and a change in pelvis position, so for example an anterior tilt, then you have a higher stretch of these muscles. And so it means that if I am not able to control my pelvis with my muscles, then maybe I will have a higher strain in some cases. This has been beautifully shown in a study using cadaver by Jordan Mendigucha at the University and the Hospital of Barcelona. This was in Marca newspaper some months ago, and I'm going to comment briefly on this study. So this wonderful study has been published a few weeks ago, and basically here there is a video online that summarizes the study. But just to explain new things, we observe some injuries when some movements of the pelvis tilt too much, because as you can see here, a tilt of the pelvis is associated with more stretch in the muscle. So you need to be very careful and not mistake the hip angle, that is the angle between the trunk and the thigh, and the pelvic angle. So what Jordan is showing here with the cadaver preparation of a lower limb is that you can have the same angle at the hip and move the pelvis, so have the same hip angle and very different pelvis angles. And what is inducing the strain in the hamstrings is the pelvis angle. So in that study, he was able to control a lot and to control very well the hip angle, the pelvis angle, and to show what was the stretch associated in the hamstring muscles for 5 degrees of hip angle changes, and also for 5 degrees of pelvis angle changes. And the results are very interesting. You will see the full video if you want, but basically here, you see that in this slide, when you increase by 5 degrees the hip or the pelvis, you have a stretch in the hamstrings that is 0.5 centimeters or 1.2. And so it means that this is a totally different approach. And then the idea is to say, if you want to reduce the strain in the hamstrings, then maybe you should consider having less pelvic tilt in the movements at very high intensity. So this is something that we have measured. This is something that we have worked on. And as you will see in the end of my presentation, we did a study where we were able to reduce the tilt of the pelvis by about 5 degrees, which means reduce the stretch in the hamstrings. And so maybe, very likely, the strain in the hamstring and the risk of injuries. So now let's go back to this idea of course, it's important to work on the capacity. I didn't say that we don't need to work on strength. It is a part of prevention. But for some players, we need also to focus on the strain, the mechanical strain, because some players maybe run with too much strain, and there is no way you can face that strain with increasing capacity. What you focus on is reducing the strain. So in the years 2016 to 19, there has been some studies emerging, and the first one was not about sprinting, but it was very interesting. the team of Christopher Brahma, they asked some runners to run at their lab, and they measured their 3D kinematics very well. And they wanted to see what was the difference between runners who got injured and runners who never got injured. The two factors that were very, very consistently different were the trunk lean, so the movement of the trunk, the incline of the trunk laterally and anteriorly, and the drop in the pelvis at the moment of touchdown, which means at the moment where the ground reaction force goes up through the body. If there is a drop in the pelvis or a lateral flexion of the trunk, there is a higher risk of injury, of being in the injured group. And this is very, very fine line changes, because 1 degree of anterior pelvic tilt was statistically associated with a much higher risk of being in the injured group. So this is retrospective, but it means that, as you can see here in the example, if you're not able to control the movement of your pelvis, very likely there's going to be some strain in the structures and eventually some injuries related. Of course, my dream is to have this kind of study in sprinting, and this is what we are working on. Talking about sprinting, there is one single prospective study that is with only 4 injured players, but what's important is that all these players had something very different mechanically when they measured pre-season. So here they did some 3D analysis of their sprint mechanics. When they measured pre-season their sprint mechanics, they saw that compared to the players on the same team, it was football, who did not have injuries, these 4 players all had a greater anterior pelvic tilt at the moment of touchdown, at the moment of touching the ground, and more lateral flexion of the trunk, which means that very likely when they sprint, they have more strain in the muscle. And so maybe that's a reason why they got injured more than the other players. So more anterior pelvic tilt, more lateral trunk flexion means more tension and very likely a higher risk of injury. So the idea is not to prevent all types of injuries. We know that football is chaos and not everything can be controlled. But the idea is to have the players more able to control their trunk and their hip movements. Let's see the only hamstring injury of Kylian Mbappé, the French player. So as you can see here, he's going to sprint. Everything is okay. The balance between capacity and strain is okay. There is no risk. And the defender will come and take his shoulder and rotate his shoulder. And you will see that at that moment, he will grab his opposite leg, and that will be the moment of injury. So let's watch the video. Okay, and he's a very fast player. So it means that he's going to pick the ball, accelerate, run super fast. Everything is okay. And then boom, rotation of the trunk, injury on the other side. My interpretation of this video, and this is not perfect science, but my interpretation of this video is that he had the capacity to run, but because of the huge trunk flexion and the very fast the very fast trunk rotation, there has been an increase in the mechanical strain in the hamstrings. And this increase in the mechanical strain, he was not able to match it with his force capacity, and there has been a tissue injury. So I don't say that we can prevent this injury. I just say that if we focus on increasing the trunk control, the trunk discipline, the ability to resist huge trunk movements and pelvic movements, maybe we can reduce the risk of strain and maybe the risk of injury. And this is what I observe a lot in tennis or in basketball. And the cool thing is that there are some studies showing the link between lumbopelvic control, that's what we call lumbopelvic control, and the risk of injuries. For example, in baseball, in the Major League of Baseball, there has been some studies showing that the players with a lower lumbopelvic control, that is a lower capacity to control the tilt, the drop of the pelvis in some clinical tests, had higher injuries during the season. So the last part of the presentation will be exactly around that. We will focus on the sprint pattern. We will focus on the movements of the trunk and around the pelvis and what contributes to a higher strain. So we want to assess that, interpret that, and maybe change it. To give you a summary of the points in the sprint technique, in the sprint pattern that we think are related to the strain, and so maybe to the risk, these are two students. So I did a slow motion video. I stopped the video at the moment of touchdown, and this is their body position. So this is their sprint pattern at the moment of touchdown. The very big difference between the two students is in the trunk lean. You see that the green student has a trunk that is much more forward to the vertical. The trunk rotation, you see this is opposite shoulder, which is a lot of rotation. So incline rotation brings even more tension. There is a huge distance between the knees, which means that there is a high torque around the pelvis, and maybe that brings tension in his hamstrings in addition to what is normal. You see that the distance between the knees in the other student is clearly different. So why is that? Just because the second one didn't have enough hip flexion and didn't have enough leg retraction on the other side to have this scissor quickly. The touchdown distance is very different, which means that when the force vector, because the ground force vector is going to go through the contact point, there is going to be a huge lever at the hip. And finally, you can see, even if you are not measuring it precisely, you can see that the pelvis is more tilted forward on the right player than on the left player. The left player has a more neutral tilt position. So all these factors have been summarized in an index, in a score that has been presented by Chris Brahma last year. And we have summarized all the mechanical factors that could contribute to hamstring strain in a study published in Sports Medicine. This one is open access. And we have this big table where we take all the variables, we explain why is it mechanically related to the strain in the hamstrings, and then we explain the level of biomechanical evidence published today that tend to support the use of this factor. So all these factors have been integrated into the sprint assessment score of Chris Brahma that I presented you at the beginning of the presentation. And so it means that you can clinically think about this score and see if you have a high score, which means you have a high strain, or a low score. And then, if you have a high score, you can consider improving things by working specifically on the sprint pattern with a specific type of gait retraining. So, the big question is, can we change, can we correct the sprint posture? And the answer in short is yes. If we work specifically on that, so there has been a study in our group with Jordan Mendiguccia in which we presented a program that is done with many different exercises. Everything is online on the Zentrum. This is the rehab center of Jordan, on the Zentrum Center on YouTube, for example. And this program is 2 or 3 small sessions per week, and all the exercises are related to better controlling the movements of the trunk and better controlling the movement of the pelvis. So you can do these exercises. This is the exercises that we have integrated into the program. I will not take too much time here, but you see the idea. And when we took some, and of course there is some bouncing, some plyometrics, some exercises where we regulate the lumbopelvic control. And when we took some volunteers to have this program, this is something that I now use today with athletes I work with very, very often. We were able to change the running mechanics. And my observations is that you can also change that in high-level people, in trained people. The body is always able to adjust to some new type of training. And so in that study, we did a comparison between a control group who did nothing special and an intervention group who did our program, the program that's in the video. And we saw the main corrections were clearly, and the effect size was large, the distance between the knee at touchdown, so we were able to have a better score on the distance between the knee, the anterior pelvic tilt during the entire running cycle, and the anterior pelvic tilt at the end of the swing phase, which is just before contact. And so it means that all things equal, we think that at the end of the program, the players run with a lower strain in the hamstrings. I don't know if this was a good prevention because we did not do an injury, prospective injury follow-up, but everything equal, they run with less mechanical strain. So I think that if they have the same dose, the same exposure, they have very likely a lower risk. The very interesting thing is that in addition, this program increased the sprint performance. So it means that they run better in terms of mechanical strain, but they also run a bit faster. So again, it was not elite people, but still this intervention centered around the trunk and the pelvis and the movement of the legs improved sprint performance. So it means that it is maybe a prevention approach that can also be related to a better performance. So it's a win-win approach here. So this is the end of the 45 minutes of this presentation. If you have any questions or if you want to follow up, feel free to connect with me through my website, jbmorin.net, and try to find some way to have some connections during workshops or direct teaching to maybe understand the program and maybe see how you can implement, how you can put this program into practice. Believe me, all the players, all the structures I worked with who started considering this program, they never stopped afterwards because they see and the players see that it's useful for performance and that is very likely also useful for prevention. It is not a magic stick, but very likely it will help the players run with less mechanical strain in the hamstrings. So, gracias a todos. Thank you very much, and I hope you enjoy the rest of the conference. Bye bye. Cheers from France.
Nuestra escuela universitaria es una realidad sólida y nuestro proyecto académico está muy consolidado. Nos habéis elegido a nosotros. Es un honor y también una gran responsabilidad.
No solo en el Real Madrid formamos jugadores.
Uno como estudiante viene aquí para ver, ¿verdad?, cómo uno puede crecer como profesional y es el inicio de ese proceso de crecimiento profesional que la universidad nos está brindando.
Elegí en su momento estudiar aquí por el prestigio que supone el Real Madrid, la marca, y también la Universidad Europea.
Creo que es de las mejores opciones que puedo elegir estar en el Real Madrid. Solo la marca Real Madrid ya te abre muchísimas puertas.
Algo que lo pueda hacer con pasión.
El trabajo en equipo se mantenga independientemente del resultado.
Esos valores se adquieren cuando tú ya tienes ese compromiso desde que entras al club, ¿no? Y al final tú vas haciendo una especie de pasar el testigo con los que van viniendo después.
Y tener las herramientas y los conocimientos técnicos necesarios para poder liderar una transformación que tiene que darse ya en este tipo de industria.
There's really no other opportunity like this in the world.
Okay then, so although Maureen is not listening to us, I would like to say thank you from here for his amazing talk. Well, guys, we'd like to wrap up today's session. Thank you very much for connecting from all over the world. It has been quite an intense day, but I think it has been very positive and rewarding for all of us. So see you all together tomorrow at 4:30, according to the agenda. Tomorrow you will be with the other manager, Guillermo Munoz, who will be with you during the whole afternoon. So to say goodbye, good evening, good night here in Europe, and a good day in Latin America. So cheers!
What feeds effort? What feeds motivation? What feeds victory? With the most advanced scientific research, with the quality of the best ingredients, protecting people's health without banned substances and with transparency. Crown Sport Nutrition, your personal best brand.